So this is all about our school and infra and as well as our management. Now I like to call Professor Mr. Rajesh, the President of IFPEFSSA and Organizing Secretary of World Conference and Access Medicine. We like to give on behalf of the momentous to the Mr. Rajesh sir. Sir, please come on the stage. Yes, sir. Yes, sir.
I request Dr. C.P. Muhammad Lee to come onto the dais. The Guardian School will facilitate him on behalf of Guardian School. They are honoring you with the mementos. Another memento to host, I request Professor L.B. Lakshmikant Rathod, Vice Chancellor of Parliament University, to take a honor of getting a memento, honor from the Guardian School. Please clap hands. Professor L.B. Lakshmikant Rathod, Vice Chancellor, is the only Vice Chancellor of higher education in our country. I request Balaji, please honor him. Now our session is going to start. I request Dr. Tara Singh to take charge.
Good morning. Good morning. Shall we have another session by Ada Sanda? Aerobics to start off. Yeah, okay, now we'll have a technical session. So the first session of the day, due to the unexpected rain, it was delayed a little bit. So let's start off with no more delay. The first speaker, Professor Ashok Kumar from India, and the topic, dose response profile to improve cardiovascular fitness. I request silence from all the delegates attending the conference, as it's an open air auditorium. And the chairpersons for the session, Dr. Ruma Bishwas and Professor K. Deepla. I request both the professors to kindly chair the session, and I hand over the mic to Dr. Ashok Kumar.
Hello. Good morning, everybody.
So dose response profile to improve cardiovascular fitness. So as we know that cardiovascular fitness is also referred to as aerobic fitness, and mostly in our research in theoretical aspects, it is expressed as a VO2 max is there. So VO2 max is nothing but what was the maximum volume of oxygen which we can breathe in, and you can take it through your lungs and pump around your body using heart and blood vessels, and it ultimately goes to what's what in the skeletal muscles, where we will get the energy in the form of ATP, and body movements are there in the different body movements are there. So it's not working. Sorry, there is interruption is there. So pointer is not working. You can change the battery. Wavelength is okay. You can change the battery. Battery has not gone. Okay. So the purpose of this lecture is to give what's what the awareness is there about the physical activity which we have taken since yesterday. Okay, now it's working. Since yesterday, and but sort of the theme of this conference is there, that is exercise medicine is there. So medicine here, it does not means that the chemicals and biochemicals are there, but it is to some extent related with that. So what is dose? That is dose. Dose we will very familiar with in our daily life, but it is particularly perceived from the medical angle that what dose is there for the medicine. But in research, particularly in the exercise sciences, we will see that the dose means that is it is a what sort of the three components are there in this dose. So exercise variables are there, training variables are there, and different principles of training. That number of principles are there. So all these three ingredients makes what's what the dose in exercise sciences. So in training particularly, the dose means exercise variables. In exercise variables, as we know that exercise intensity.
All the participants, we are appeal not to talk. If you take the tea, you take tea, please sit down. Don't talk each other. Disturbing the please. कोई भी बात मत करो सर आप लोग. See, if you are calm, no, everybody can listen.
Thank you, Dr. So exercise variables, for example, exercise intensity is there, exercise duration is there, and type of different types of exercises. Then training variables, particularly we'll see the training angle is there, that is frequency of training sessions in the form of microcycle, mesocycles are there, and keeping view what's the aim, the different principles of training cycles. So all these three ingredients make a dose. So here in exercise sciences, in training sciences, dose means the three components should be there. Sorry, there is a problem in the pointer. It is not working. Some range problems may be there. So please, Anurag, please check it. Okay. It is moving so fast. I think. So next point is there. What is the difference between physical activity, physical exercises, physical training? Although in our daily life, we will use this word interchangeably. Sometimes we will use physical activity, physical exercise, but from the point of view of physiological angle. So we will see physical activity is a muscle induced body movements that increases the energy expenditure more than 1 or 1.5 MET. So MET, as you know, that is metabolic equivalent is there. So hence the term physical activity is a hypernium. That covers a wide range of physical activity that conducted on a regular or unregular basis in a relatively unstructured and unplanned manner. So that includes what's what the specific planned structured forms of physical activities that are known as physical exercises. So physical exercises can be distinguished based upon the temporal characteristics. That temporal means with relation to the time. So how much time is there? So on that basis, we will again use the word acute and chronic. So these two words or these two terms, again, we will see in the medical or the clinical side. But here we will distinguish words for the exercise sciences is there. So acute physical exercises, that is the single bout exercises are there. And chronic mean physical exercises, that is the repeated bouts of what's what acute exercises. So what's for the single bout? That single bout of exercises, that is physical exercises, is commonly referred to as acute. Single bout of physical exercise or acute physical exercises. So further, I will just a little bit elaborate what's what the chronic here means. So clinical, I repeatedly again, don't confuse with the clinical side. It is from the exercise sciences. Now, in these days, we will use these terms. So chronic physical exercises can be defined as physical training. So physical training when they are conducted regularly in a planned, structured, and what's what some purpose is there and some objective we want to achieve it. So in training, either we will improve the things or maintain the things. So it is individual capacities or multiple dimensions are there. So acute and chronic words we have used it. So then word is there responders and non-responders. That is that question is related with the training. So slowly I move towards my aim. What's the aim of this lecture is there? So as we know, every human is unique. What's what their makeup is there. So there is a what's what the considerable amount of within individual differences are there that we call intra-individual, and between individual that one individual to another that is called inter-individual. So two words are there, two terms are there, intra and inter words we have used. So research studies have shown many things that these terms are not designed on any references there, but research is designed that these words we have used in these days in the training. So in acute physiological responses to the same acute physical exercises and or long-term adaptations to the same physical training, there is a lot of variations are there in the different physiological parameters. So in order to account for these inter-individual differences, a heterogeneity, the concept is another concept is generated. Another words we have used it, that is the responders, non-responders, and limited responders are there. So responder here means it is refers to the individual with high sensitivity to any change. That is, we will use the word responder. Then non-responders are there. So those responders, that is the individuals with the low sensitivity to any change in the what's what we can say internal and external, that we will discuss in the next slides. Then limited responders, that is individuals which did not respond and was introduced later on, this third term in the research literature. So now how genetics, lifestyle contributes to this inter-individual what's what the heterogeneity is there. So inter-individual responses to physical exercises and or physical training, in turn, individual heterogeneity in outcomes are caused by several moderators, or we can say several factors are there, which includes non-modifiable and modifiable factors. Non-modifiable factors are those which we cannot modify it, like our genes are there, our sex is there. But the modifiable factors, for example, nutrition, our social lifestyle, cognitive activities, exercise perception, mean exercise part of training of exercise. These are the modifiable factors are there. So notably, but these factors can also classified in another way. In another aspect is there, that is called endogenous factors and exogenous factors. So these medical terms now we have used towards our physical training and towards the to get the what's for the fine outcomes of the training in the form of scientific basis. So endogenous represents what's for the internal is there. So factors attributable to the individual such as sex, again, genotypes are there. Exogenous, the same thing is there. That is the factors attributed to the external inputs. that is generated by exercise perception. That in exercise perception, we will see the intensity and frequency, other things are there. So this makes what's what the inter-individual variability is there. Now what external load, internal load is there. So in this context of exercise perception, it is also imperative to clarify what sort of the term external or internal loads are there. So while external load with influencing factors, for example, climatic conditions are there, what sort of the ground conditions are there, equipments are there. So these are the defined as the work, what sort of the completed by individual, independent of what sort of the internal characteristics of the persons. So internal load is defined as individual and acute biomechanical, physiological, and psychological responses to the influencing factors. That is, the external factors are there, which is performing, which influencing the performance of the individual. So it appears that internal and external can be adjusted by modifying the external factors. That what our genetic makeup is there. That is more, we can change it by using the external factors. So, but you see the exercise variables such as exercise intensity can be operationalized using parameters of either external load running with, for example, running with a speed of 10 km/h, or internal load with running with a 60% of the maximal heart rate. So interindividual responses to physical exercises and physical training, and in turn individual heterogeneity outcomes are caused by several moderators, including this external load, along with influencing factors like climatic condition, equipments, and other things. I have just repeated thing. So dose is an essential factor. So what I have defined earlier, that dose is comprises of three components are there. So dose is essential factor for triggering the what's what the changes in the body, that is the neurobiological processes are changing. So which in turn lead to neuroplastic cognitive changes. And although different markers of internal load could be more difficult to measure compared to the markers of external load. So what is marker, or we can say biomarkers? So these words are now again used. That is, what is the markers are there? What specific markers for internal load is needed as a proxy for the dose? So there are several markers of internal load that can be used to prescribe the exercise intensity in acute endurance exercises or endurance training. For example, oxygen uptake is there, heart rate is there, heart rate variability. So we will take, for example, heart rate variability is there. That is the beat to beat variation in the heart, that is over a distinct time period is there. So under rest conditions or while exercising, it is an interesting marker for internal load, because the internal load quantify what's what the heart rate variability. So it takes the individual fitness level as well as daily readiness acute what's what the into account. So hence it seems that more promoting and what's what the markers of internal loads are related to changes in what's what the neurotropic molecules, that is biomolecules are there, molecular level changes are starting there. So in order to what's what the individualize and what's what the adjust the exercise prescription for the individuals. So biomarkers, what is biomarkers? And particularly later on, I will come to the cardiac biomarkers because of my lecture's topic is there. So it is a very big field. So biomarkers are biological marker, which is measurable product of a substance used as indicator of biological state to objectively determine the body's what's what the changes are there, particularly physiological or pathological processes. So in sports, biomarkers are key parameters to assess the impact of exercise on different systems, tissues, and organs. So therefore, we can estimate parameters for assessing the degree of fitness, muscle damage, hydration, dehydration, and inflammation, oxidative damage, fatigue, etc., or overtraining is there. So which facilitate the evaluation of the responses of the human body at different levels of physical activity or training, which is being carried out. So biomarkers can be used to measure the impact of training on the long term or the acute factor of exercise. So the value of or concentration. So different values are there, but in the field of sports and exercise sciences, there are no standards values are there from which we can say it is deviate. Still, we are using these biomarkers values with the clinical sides. From that angle, we will evaluate and compare it and interpret the results in the research still. But no norms are available in the field of exercise sciences where we will say that runners have this normal value, sprinters have this value. It's not available. It is still research is going on. So these biomarkers are very important, keeping you what's what the health risks are there when the what's what the athletes are going under the training and after training. So I will little bit, if time is spare, then I will discuss this thing in elaborately. A little bit elaboration is needed, but time is very short. That's why I'm going to try to trim it because topic is very wide. So the value of concentration of biomarkers depends on many factors. In addition to, we will see. So as the training status of the subject, then the degree of the fatigue, exercise, that is exercise perception factors are there. And apart from this, age and gender is also matters more. With the increasing age, some changes are there in the level of these biomarkers. Climate is also there, climatic condition, as we just in my previous slide, external load or external factors are there or exogenous factors. They are also influencing the level of or the concentration of these markers. Please check my slide. A little. Okay. So climate can also play a role. Mainly temperature is there, humidity is there, and even wind speed. Here I will take this particular parameter biomechanics because wind speed in sprinting and other events will indirectly influence the what's what the physiological functions of the athlete. So exercise we can be classified according to another aspect, that is the duration is there, that is around 20 seconds demand. Aerobic energy, we will say this is 90% energy is drive when we are doing any physical activity or physical exercise. So exercise is lasting 20 seconds to 1 minute, that is aerobic and anaerobic energy demand is there on the system. So exercises that extends more than 1 minute, aerobic energy is there, that is 50% come. So intensity is what's what the very important. I will take other factors are very important, but here I will just highlight the intensity. So intensity is also influencing factor of these biomarker. What's what the concentration of these biomarkers. So most of the biomarkers in the field of exercise sciences are measured in blood, urine, and saliva. Particularly in the elite athletes, the sampling method, that is non-invasive sampling method we have used, that is the saliva is there, and urine is very easy, and there is a more compliance rate is there from the patients. Instead of taking the blood, there is ethical issues are there, medical clearance is also needed in the research. So in elite sports person, non-invasive samples like urine, saliva have a preference. So other useful biomarkers, that is body composition, that is, I will just highlight many biomarkers are there. I just see these components we have studied it in the physical education and sports sciences and fitness. So specifically muscle mass, fat mass, weight, physical fitness, cardiovascular capacity, strength, agility, flexibility, heart rate, blood pressure. So depending upon the aim, what's the aim is there, one or several biomarkers should be, we will mirror. So I again come to my point, that is cardiac. I will emphasize more on the cardiac because a little cardiac stress I needed it. So cardiac biomarkers are endogenous substances. It is released in the circulation when heart is stressed or damaged. So a long race such as marathon or ultra marathon can lead to changes in the biomarkers. Here I will not highlight. In next slide I will show you few biomarkers. Many biomarkers are there. So they changes biomarkers, even when we will see the process like electrical activity of the heart, electrocardiography, endography, echocardiography, they have changes. So they indicate that some changes are there, stress is there, damage is there. So these pathological processes potentially leading to what's what the physiopathological changes in the heart, and it occurs. So these shifts are usually temporary, depending on what's what the intensity of the exercise, what's the competition level is there, and what's the duration of the performance is there. So generally it is normalized after the completion of the performance. Here in this picture, you will see, I just take a very small picture. I just told you again and again, it's a very vast field. I just highlight it, and it is a educational awareness lecture is there, not clinical. So in this picture, what's the mechanism is there when we do any physical activity? Generally, we know heart rate is increasing, breathing rate is increasing. But here I will emphasize that heart rate is increasing. A number of things are going to be changed. No doubt, physical activity is needed. Physical exercises are needed to get fit. But since you see from the last many years that we have seen that in the gyms and other physical activity during walking, during running, some mishappenings are happening, that fatal conditions are there. So why that is occurring? A little bit things are now comes in from this angle, that when you are doing exercise, you don't take these biomarkers into view. Generally, we will take the cardiac profile, like triglycerides are there, cholesterols are there, other things are there. So if they are normal, we can say our heart conditions is good. But still, these biomarkers now they have used in developed country. It is mandatory to check these biomarkers before going to in any gyms and any activity. So these biomarkers are very important, which I just highlight here, because it will reduce the risk, health risks, whether it is a common man or athletes are there. Because with training, we know that athlete's heart is there. In athlete's heart, with the particularly endurance training or long distance running, the left chamber of the heart is increased, left wall is increased. So that makes a good heart. That resting heart is going to be down, which will indicate that is a good indicator of fitness, that resting heart rate is there, because vagal tone is increased. That is sympathetic, parasympathetic. There is shifting is there. But when you see, when we are doing any physical exercise, skeletal muscles are there, it is going to be increased. Same thing is happened with your heart. So heart is involved with many membranes. So when you beat it, so it will go to touch. So myocardium is there, chamber is enlarged. So whether it is normal, because heredity is there, genes are there, in some persons it is good, but other persons, they will slowly make it fatal and risky. But the profile which you have used in cholesterol, that is related to your diet, that is related to your lifestyle. But these markers are used particularly what's for the intensity, duration, acute responsiveness, which I have earlier told you, to tell us the risk that sudden cardiac deaths are there during the performance of the athletes during the gyms. So here you will see that we will see the high exercise intensity is there, that is in the sprints, weightlifting, when you do suddenly. Because you see in these days, when there is any sports events are there, sedentary persons or common persons comes and marathon races are there. Cyclists, they are doing the long distance running, cycling, particularly the persons who are above 40 or 50 years. Before that, they are not doing any physical activity. So that's why when you are suddenly put so much stress on the heart, particularly skeletal muscles have another problems. But here I will highlight that when you do any exercise, particularly comes from the sedentary life to the other, and the persons who are already trained, how much stress, how much intensity they will take, so that these markers should tell us the indications, what indications are there. So in this picture, you will see that high intensity exercises, there is a myostatic mechanical stress is there. That is when the wall is touching, the stress is there. Mechanical, it does not mean the weight the dumbbells are putting on the skeletal muscle and it comes on the weight of the heart. No, it is the pressure and the volume of the requirement. So in this picture, you will see a number of changes are there. Myostatic mechanical stress is there. That will lead to ischemia, and hemodynamic consequences are there. Then you will see acid-base imbalance is there. Acid-base imbalance, when do we exercise, more acidic blood is there. More words for the this acid-base balance is again give the oxidant stress. Oxidation is more. That is, the free radicals are going to be produced more in the system, particularly in the heart walls, in the heart muscles. So inflammation is also there in the heart. So these what sort of the conditions give us these abbreviation. I will just elaborate in my next slide. These are the markers which will tell us the status, molecular status, that how fatal, how it is good, whether the inter-individual variation is there, whether the body is able to adapt it or not. So these are the few markers which is commonly used in these days in the search of sports and exercise sciences. So in the previous picture, I just give the abbreviations. But here I will just a few like troponins. So these markers now in these days are also used by the clinical side. When anybody gets some doubts about the particularly the heart attack, doctors have immediately put this marker to check it that heart attack is occurred or not occurred. So these molecules tell us that is the troponin is there. So doctor says that half an hour or half an hour ago the person is suffering from the heart attack. So these molecules tell us the concentration of the blood. So troponins are there. So troponin 1 is there, troponin T is there. So troponins tell us the myocytic injuries. That is the myocytic injuries are there. So troponin 1, it is show us that ischemic necrosis, myocardial infarction, and cardiac risk. These functions tell us these biomarkers. Then troponin T is also there. So then B type natriuretic peptides are there, which will also tell us the myostatic stretch. That is how much stretch is there on the heart muscles are there, cardiac muscles are there. When it is overstretching, these chemicals are released in the what's on the blood. It comes into the blood and tell us the status that overstretching may lead to some risk. So B type natriuretic peptides are there. So two types which is commonly used, B type natriuretic peptides, BNP is there, NTP, PRNO-BMT. So these will diagnose, prognosis, and monitoring the heart failures, particularly both in the common man as well as in the trained athletes or the persons who are under the training. Then there is galectin-3 is there. Galectin-3 is the mediator of cardiac fibrosis and what's for the remodeling of follow-up heart failures. If heart failure is there, to check and follow up whether the medicines and the rehabilitation is okay or not. So these markers are used. Galectin-3 is there. Then suppression tumorigenicity, ST2 is commonly used. It is again for the cardiac fibrosis. And others are there. Heart rate, what's for the heart fatty acids binding protein, HFABB is commonly used. It is myocardial damage, that if any damage is there, like skeletal muscles, there is a damage is there, sometimes rupturing of tendons and ligaments, muscle tearing is there. Same thing has happened to the heart. What's the heart is there, if any damage is going to be started, then these markers tell us the concentration of these markers, that is the HFABP tell us what sort of then is copeptin is there. So copeptin is again, it is related to what's what the vasopressin, that is stress related, what's what the mechanism is there. So these few markers are there, which are tell us what's what the status and risk status is there, although we are doing physical activity, whether it is aerobic is there, anaerobic is there, mixed type is there. So in addition to those profiles, cardiac profiles, which we have used keeping view of our diet. So these tell us the actual status of your body. What's the effects of your exercises? Different exercises are there, and it varies from person to person because heredity plays a very big role here. So how to individualize these exercise prescription, keeping you this aspect also that health risk should be assessed always. But in India, no such thing is there. I just again remind you that these are the educational purpose, but in developed countries, but in India, only clinical sites, some higher institutes like PGI, AIMS are there. They are using these biomarkers in the clinical side, but nobody is using towards the sports and exercise sciences. So they are not, because ethical issues are more. When you are designing the research, ethical clearances are not cleared very easily. So the ultimate aim of this, that how we will get the maximum. So training is generally given by the mass, that is the number of athletes are there. We will not, we will compromise what's for the individual uniqueness of the athletes. So to overcome, to get the maximum, particularly from the cardiovascular angle, we need some individualization programs, exercise programs are there. First, we will assess it, then we will design it. So how to individualize the exercise prescription? So based on the large individual intergenity, physical responses to acute physical exercise, and what's for the long-term adaptations to training, it is assumed that tailoring of these to the characteristics needs of a particular person will suit the maximizing efficiency. What's the efficiency is there? What's what their body markers tell us? So such individualization of acute physical exercises and physical training could be achieved by adjusting the external factors, that is in the form of exercise prescription, that is that factors are there, particularly the exercise intensity is there. So in practical terms, focus on exercise intensity, because a full discussion of all exercise variables training variables and training principle is beyond the scope of my lecture. This lecture is not sufficient to cover these things. So as outlined in my previous slides, so using markers of internal load to prescribe exercise intensity, it is a preferable instead of using the parameters of external load, such as speed in running or in specific exercises. Therefore, traditional markers of internal load, such as the fixed percentage of maximal oxygen, achievable value of oxygen uptake, heart rate used. So these markers we will use, but in addition to this, we will use the new ones also, but the internal variables or internal factors will also be considered. For example, in this, we will take that using a fixed percentage of maximal oxygen value, you will also use what was the internal load, like the level of the blood lactate along with the peripheral blood. So traditional exercise prescriptions lead to large variations in the individuals. So in this context, individual thresholds are playing very important role. That is towards the training. When you are choosing the purpose and aim, so what's the individual threshold is there? That is aerobic, anaerobic threshold. So there is a strong theoretical basis for the application of threshold exercises, prescription for particularly the endurance exercises, endurance training. So challenges are there, pitfalls are there. So for these achieving, so I just come to conclude my lecture here. So what's were the purpose and what's were the things which I have highlighted here, that to get the maximum, what's were the profile of cardiovascular, particularly from the heart and heart related systems. So dose is very important. Dose is comprising of again 3 factors, which I earlier told you. So dose is the exercise in the exercise research is a very important, and it evidence how individual variation is there. So dose of acute bout exercises for physical training should be operationalized by specific markers or specific markers of internal load. So modifying the exercise prescription means exercise intensity, exercise duration, whatsoever is there. So carefully adjusted that we will achieve what the aim is there of that training program. So understanding how a comparable dose affects the physiological outcomes is an important step towards where the identifying what is the dose is there for particular athlete, particular individual, so that we will get less risk of cardiovascular system and get the outcomes, maximum or optimum outcome should be there. So with this, I just conclude my lecture. So the field is very wide and topic is very wide. I try to give a little bit awareness, educational awareness, because these terms are used towards the clinical side, but now it is used towards the field of sports sciences, exercise sciences is there. So thank you for listening to me. And if any queries there, are you?
Thank you, sir, for your excellent lecture. And you are giving about exercise physiology, physical exercise, physical training, and everything, and load and everything. You are given a lot of information about exercise physiology. And I thanks to Professor Rajesh Kumar and Professor Lakshmikant Rathod. They are given opportunity to as a chairperson in this today's section. Thank you, one and all.
Thank you. Please listen. Thanks. Yes, I have not touched that. One slide I have shown you, that is adrenal link stress hormones are activating what's what the heart is there. So that neurotransmitters are not directly but indirectly activating the things. And there is a membrane inflammation is there. That's myocardial, which leads to ischemia. So I have a number of studies with me in my literature, from which I have make my lectures. Beyond, I will share you just now that what the neurotransmitters are there. So which exercise, particular, yeah. In research, I have papers with me from the USA and other countries. The marathon runners, particularly the marathon runners, have stress. That physical stress leads to the mental stress, and neurotransmitters are there. Even cortisols and other hormones are directly or indirectly elevate this problem. That is more cardiac risk is there. So
next question.
Thank you.
Last third,
it's a
third
good
session.
question, but I have a lot of research I have done. Dr. Lim, thank you. just tell you, elaborate, you listen to me. The cardiac athlete is there, that we will say athlete's heart. So athlete's heart say one characteristics is there, particularly the persons who are going aerobic exercise and long distance, their resting heart rate is come down. We say the heart is efficient, that with less heart, stroke volume is increased, that cardiac output is more and heart rate is less. But in the research with me, these biomarkers which I don't validate, their concentration is increased and they will lead to inflammation, damage. That is septum of the wall, left ventricular wall is also thickened, chamber volume is also increased. Act as a stimulus to give certain cardiac death in the sports persons, because these markers are suddenly increased and they damage the system and stop it. So this is the reason. But behind this, again, I told you that genetics play a very important role. Genetics, genes, but still the field is not doing any research ki which genes are make more probability towards a sudden cardiac death, because genes are controlling these biomarkers. So these biomarkers, but athlete's heart is a one of the stimulus to give sudden death. This research told me. This research, that is biomarkers of cardiac, particularly cardiac. So the athlete's heart, we say it is a good, that our heart is resting heart rate is good for marathon, but that leads to suddenly they make more probability to sudden cardiac death. So this is the reason. So all these biomarkers, not only single biomarker, so combination of these biomarkers are there, ST2 is there, component is there, the elevation is more in those persons who are going long distance running. I just tell you marathon running, in the gyms they are doing what's about the aerobics, suddenly there is a collapse is there. And this is one of the reason I have also come to know, that the persons who are starting their physical activity in the 50 years, 40, 50 years age, that they become fit, or suddenly those persons who make a marathon running in some occasion, some particular days, that before this there is no, but cardiac stress is there. Cardiac stress is a word like Vrinder sir is there. It is a condition to the heart, like psychological condition of the brain is there. So that condition damages particularly the membranes and the cells. So they will release it. Overstretching is also that when heart is standing, more beating is there. The muscles, cardiac muscles will release this concentration. Like when we are, our skeletal muscles are there, their stretch reflexes are there. That is special sense organs, Golgi tendon organs, they send the information that how much pain is there. Cardiac system. But it is not, we are not studying in a master's level in theory, but in research it is open. So many persons who have given these studies, where I will take the lectures, they are both from the physical education and what's for the sports, and the medical persons are doing research, not in India, but in abroad, that is USA, UK, Australia. I have a number of studies with me.
Last question, sir.
It is again awareness about my colleagues and friends, that we are where we the science of sports and physical education reaching. It is moving very quick. Molecular level, it is so much. You see, in my department, I opened the biotechnology persons for doing PhD in sports sciences because of things. Because they know how to isolate the DNA, how to isolate the what sort of these biomarkers. Kits are there, but the persons who don't know the techniques, that is a limitation. So that whenever you get an opportunity here, you explore this field also. That is molecular chemical field is there. Particularly molecular exercise physiology. This is the molecular exercise physiology is there. Exactly, I just told you that there is no norms are not there. Norms are not there for the sports person, but the norms are available for the clinical conditions. Presently, we are taking these values and interpret on the clinical side, like heart that is there. So in the general population, what's the biomarkers are there in those persons, but those persons have some other complications, like obesity is there, hypertension is there, other problems are there. But the sports person, we have no such other complication, but still for interpretation of result, until not huge data is there, no norms are available. But we will compare one study to the other study, and particularly the clinical side interpret the results. So when it is available, like you will see BMI is there. So BMI is for general population. For sports person, body weight is more, but it's from the muscular mass. But general population is the fat mass is there. So on the basis of BMI, we will not say that the athletes are bad. Their health is not, physique is good. Physique is not good when we compare with the common. Because now norms are available. But for these norms are still not available. The research is started and it's going on. So that's I'm not in a position to tell you. Thank you.
Excuse me, anybody want to have more questions? No, you can talk afterwards, because at here the speakers are sitting here only. They don't go anywhere. You can talk later, because one go, because we are having less time, because it is also online. Everybody can put one question. That is very easy. Answering is hard, and time difficulty is there. I request Vrinda sir, please honor the Ashok sir with a certificate. Please, Ashok is a
Exercise to come to
sports physiology professor. Please.
Thank you for your support. Thank you.
I request Tara Singh, please start the next session.
So I request Dr. Gurnam Singh, sir, to kindly join the chair. And the next session is by Dr. Hajbullah Ismail from Malaysia. I invite the speaker onto the stage.
To me. Excellent. That's right. Yes, President. Already got it. Namaste, Boganara. So, thank you very much for inviting me to share some of the knowledge in cardiac rehabilitation. So before we start, can we do some demonstration? So hopefully that we can have better understanding. Can everybody just stand up for a while? All right, so normally guys, when we do yoga or sometimes we do some meditation or even breathing technique, deep breathing, what normally we do, we inhale deep and then we exhale. Let's do together, because I think today in the morning, very nice weather. I think let's enjoy the nice weather before we talk about something very scientific and clinical a little bit. All right, now inhale. Deeper. Hold 1 second, 2 seconds, and exhale. Slowly exhale for around 6 to 8 seconds. And then now inhale faster for 2 seconds. Inhale. Stop for 2 seconds and exhale slowly. 1, 2, 3, 4, 5, 6, 7, 8. Okay, one more. Inhale faster. And then exhale. Okay, thank you very much. Sit down. So what we did just now is a deep breathing. So I want to give you some scenario. If you are sitting down like this, during resting, we suppose can inhale like what we did just now. Suddenly we can't do that. Suddenly we feel very hard. Suddenly we feel like there is not enough of air to inhale. That's the thing that we're going to talk for the next around 20 minutes. So the things that we inhale is the air, and the fraction of the air is the oxygens. So we inhale the oxygens to enter to your heart, and then from the heart we go throughout your body. So once the demand of your heart of oxygens is sufficient, and then the supply also sufficient, demand and supply balance, you don't have any problem. And that's good. But once you inhale, that's not enough of supply of oxygens. And that's because of your blood vessel to the heart suddenly having a problem because they have a small, this is your blood vessel, small area inside there because of fat that inside the body, or even because of your cholesterol, the fat together with the cholesterol, then we get atherosclerosis. And that is the plaque at the area of your blood vessel. And then you can get less of oxygens. So once you inhale like just now, you only can inhale a little bit of oxygen. It's not satisfied. Same thing also on the demand things of your heart. Your heart is not strong enough to get this blood, to get these oxygens, because of the weak condition of your heart, because of the problem that having to your heart, so you cannot get this oxygen. And guys, the imbalance between oxygens, between supply and demand, we call as the myocardial ischemia. So this is the topic that we're going to discuss today, myocardial ischemia. And let's go specific. For most of you, I can see that you can do the deep breathing very nicely just now. Imagine that you don't have any coronary artery disease situation. Guys, I'm going to focus our discussion today on coronary artery disease patient. This is the patient where they have a block or have less of oxygen can enter to the heart. And that's happened because of several risk factors. So perhaps something can be appreciated if we understand the coronary artery risk factor threshold first. What are the things that can let you getting the coronary artery disease? The first one, because of the smoking. If you smoke, the risk factor, you already have one. If you have diabetic, or your glucose level of your blood is already more than 5.6, you already second. You already have two risk factor. If your blood pressure suddenly go higher, blood pressure more than 140 of systolic on the top and the bottom is more than 90, either one, that means you are already have 3. Number 4, because of fat, BMI very high, obesity, that is number 4. Number 5, because of cholesterol, of course, the cholesterol level. And number 6 is genetic. Your parents, your sister, or your mother, before the age 55, only women having a problem of bypass, we also have a risk factor to get a coronary artery disease. And the last one is a sedentary lifestyle. This is the most important thing. When we talk about sedentary lifestyle, that is physical inactivity, or what we call for the last 2 days, we talk about physical activity, right? So the problem on this coronary artery disease, guys, when people start doing the exercise, suddenly they can get heart attack. And in the same time, doctor tell you to do the exercise to prevent for you to get a heart attack, or to do some rehabilitation to make sure that you have a very good condition of your heart. But in the same time, if you do the exercise, you get heart attack. So can you imagine that how very serious this thing, and how important for you to have this kind of understanding? We know that exercise is medicine, but in the same time, if you're not getting the right dose, you're definitely going to make yourself dangerous. So that is about this coronary artery disease and myocardial ischemia. And the thing that I would like to focus today is the oxygens that you are taking just now. So myself and team, we are doing a research on coronary artery disease, looking into the peak VO2. The VO2 is the volume oxygen that you consume. The volume oxygen you consume, we can know whether they are good enough or not enough based on during resting. Normally, the demand and supply, once your body need the oxygens, normally your supply always have a reserve. They always a reserve. But in certain condition for coronary artery disease, there is no more reserve in terms of the oxygens. That's why during sitting down like this, they can get so-called heart attack or any complication to the coronary artery disease. Can you imagine another next stage? When you start doing the exercise, the demand of the oxygen higher, but the supply is very low. So you're going to be more dangerous during resting. So this is the thing that we need to discuss. But in the same time, this is the second day already, and I can see that no doubt most of the presenter already present the best idea, and the conclusion from the previous presenter, even myself, still the same. You need to do exercise in order to make sure that your heart getting better, stronger, and in the same time, you get the peak VO2. But how to do that is another thing. In the same time, to make sure that you are safe. Another thing is that another issue in terms of safety. While we are doing the exercise at certain intensity means effort. When doctor said, all right, you need to do exercise, do for a low intensity, low effort. But research finding shows that if you do low intensity of exercise, it doesn't give a very significant clinical in terms of your heart. It's something like no point. You need to do certain dose, moderate to high intensity. That can raise the eyebrow of most of the cardiologists. What? High intensity? But this is the thing. I'm trying to get all the studies around the world and do some meta-analysis on this. So I only managed to get 7 papers for the last 10 years talk about this exercise looking on peak VO2 on coronary artery disease. Surprisingly, for the last 10 years, only 10. That seems a little bit dangerous there. People scared to do that. However, there is another study on high intensity, high effort, and moderate intensity, moderate effort of exercise. That one, they have like around 25 studies on that for the last 10 years. And for today, I'm going to compare the study on that 7 studies that compare to the control for those who are only taking a beta blocker. That is only my introduction, right? I still first slide. All right. So the higher oxygen consumption and peak oxygen uptake can be measured for and useful for prognostic measurement to risk stratify of patient. So guys, the idea of coronary artery disease, those who have not only coronary artery disease, the risk factor of coronary artery disease is the hypertension, diabetic, obesity. For those who have this sedentary lifestyle, they are using the same stratification, the risk stratify. Why risk stratification important? We look into the risk factor of coronary artery threshold, and then we put it into certain category, whether they are low risk, moderate risk, and high risk. That is basically normally that most of exercise specialists, physiotherapists, or even doctors that doing certify them into low, moderate, and high risk. Guys, those who have more than two risk factor, you consider moderate risk already. Meaning that if you are obese and in the same time you are smoking, you are moderate risk already. And if your age is 45 years old and above for men, you also consider moderate also. Special for women. Women always special. By 55 years old only, then you can consider as a risk. Otherwise, below than 55, women, girls, you are safe. So that is the risk factor anyway. So basically, those who are lower peak VO2 and the left ventricular ejection fraction, another variable that I'm going to share is the left ventricular ejection fraction. So that is all relation. If you have higher peak VO2, meaning that you are more fit. If you fit, you know the fit, those who are fit because they have higher peak VO2 or higher VO2 max. I think most of you quite familiar with the VO2 max. VO2 max is the maximum of oxygen that your heart can consume. So, next. So this is the methodology that I did. I got a database from the PubMed, Medline, Sentinel, Google Scholar, and Sport Discuss, and from the reference. So I get all the papers from the researcher around the world for the last 10 years, 2013 to 2023. And basically the terms that I'm looking is on exercise training, peak VO2, coronary artery disease, left ventricular ejection fraction. And basically the paper that I'm looking to see and to do the meta-analysis is on randomized control trial paper. And the participants of, after this, I managed to get 5 intervention studies, and the participant is around 263, 778 is on exercise group, and 85 on control group. And using the review manager Rahman to check the statistical software power, and the result shows that this one. Oh, okay. I thought I can see that. I'm supposed to see here. Anyway, you can see that as far. Okay. Can you see that on the left side, there is a 2 section. One is exercise and another one is control. So from this study by the Cordozo from 2015, Patterson's, Roxburgh's. So on the peak VO2, they control those who are doing the exercise compared to someone only use medications. And the result shows those who are taking medication and exercise compared with the only medication, the result shows that exercise together with medication give a better impact and significant difference. And your peak VO2 increase. Unfortunately, when we didn't do any exercise, your oxygen consumption of your heart is not increased. You good, controllable, you don't have any problem of angina, chest pain, you don't have any complication, but after a while, 1 year, 2 years, 3 years, suddenly your health deteriorate, and then you will get another problem. So the only way.
Smile, sir. Smile, sir. It's really nice to hear you.
Yeah,
So here from chair. It's really nice to hear you,
Yeah.
but time is so limited. Please conclude.
all right, thank you. I almost there, don't worry. So it seems that those who are doing exercise get a better response. And let's see on this one. Same also on left ventricular ejection fraction. There is no significant difference because it's only 2 studies, but I did another study before on heart failure. You can Google heart failure studies that shows that doing for those who have heart failure can give a better response to the left ventricular ejection fraction. And on the adverse event safety on this study, there is no death, there is no hospitalization, no cardiac event happen, only withdrawal from the Rosberg study, 17 from the exercise. The rest, they are considered safe. And the result clearly shows that doing exercise together with the medication increase your oxygen consumption. And this is the supply and demand. The demand is from your heart, contract of your muscle, and the wall tension of the heart. If the wall tension of the heart stronger, you can get more oxygen. However, on the other side, supply, if your the blood flow is very problem because of the atherosclerosis, so you cannot get enough oxygen. So what happens if the demand and supply not balanced, and then suddenly you get ischemia downstairs, see, ischemia. When ischemia, you feel pain. You get ECG abnormality. This is normally doctor will check that. Metabolic abnormality, you can see through the blood taking, the left ventricular dysfunction, and the effect of medications. All right. The conclusion, exercise-based rehabilitation is always safe, but before doing that, you need to get some experts in that to prescribe your exercise to make sure that you exercise proper. So thank you very much.
Thank you, Dr. Hashibullah Ismail, sir. Since yesterday, we have watched that this area is very burning, sudden deaths and other things are happening. So it's very important subject you have chosen and described very nicely. I don't think there will be any questions or doubts. I thank the presenter for his efforts, sir. Thank you.
Thank you very much. Okay.
Thank you. Thank you, sir. I request Professor L.B. Lakshmikant Rathod, sir. Sir, to kindly come and give the certificates to the speaker and the chairperson. Professor L.B. Lakshmikant Rathod. I request the chairpersons also to join. Varun? Nandu. ఇది అక్కడ ఇచ్చేసి అవసరం లేదు. బాగుంది. Thank you all. The next session will be by Dr. C.P. Lee, the CEO of International Scientific Committee on Exercise Medicine. And to chair the session, I welcome Dr. B. Venkana, Dr. Rajkumar Karve, and Dr. Bidhan Acharya. I welcome the chairpersons and the speaker.
I also welcome Mr. N. Ramesh, athletics coach, Dronacharya Award in athletics. He'll have interaction after this also with him also.
Thank you. Good morning. Namaste. All right. I've been informed by Prof. Rajesh today because Dr. Ajay Singh is not able to present his paper due to some emergency. So to fill up a slot, and also because that yesterday after what I spoke at the opening ceremony, there were a lot of questions that they asked me, and I'm very sorry, my apology, that I couldn't answer because I was too busy with the chairman. So I think I'm going to take this time to explain a little bit more details what exercise medicine is all about. It's not going to be very technical. This slide is meant for corporates. So I just seek your attention for a little while. All right, exercise medicine has been defined as a branch of medicine to prescribe exercise. I think when we mention the word medicine, we all would understand that the basis of medicine means it has to be prescribed. When the word prescription is being used, we should understand that there should be a diagnosis before you prescribe. So in our physical world, we don't do diagnosis, we do assessment. All right, so that's how exercise medicine is being done. But then what's the purpose of exercise medicine? Well, I'm very glad to hear Dr. Ashok Kumar, Dr. Hashbola. He is very detailed prescribing it. You have gone to the molecular level, the sliced thin level. Hashbola has mentioned about even people who are on medication, having heart disease, they can do exercise rehab. And that's very, very comforting to know. Stop moving. Can someone change the slides? All right, the purpose of exercise medicine that we have started off back 15 years ago when I was serving the health ministry as a board member for the health promotion board. I was told, I was given the post as a subcommittee chairman, how to use physical activities to improve health. So I went a bit deeper to understand health by using physical activity. And when we presented this to the Ministry of Sports and Ministry of Health, and I'm very glad that the Ministry of Health has accepted the idea over a period of time, in particular with the assistance of Dr. Omar and also Dr. Vanita, where we are now working with the Ministry of Health using exercise medicine to prevent and to treat, or to use it as a first line of management for patients who has been diagnosed by medical doctors that they're having pre-hypertensive, pre-diabetes, obese, and also dyslipidemia. The reason of this working with the community, the reason of this working with the Ministry of Health, my country, of course, we all see that we spend about 9.65 billion as a direct healthcare cost. And these are certain things that we can prevent through proper physical activities. Now, I was just talking this morning during breakfast that since COVID-19, the world has begun to exercise. There has been a lot of scientific paper to say that the J curve, the benefits of exercising to improve your immune system so that COVID-19, when it strikes you, you'll not be that bad. All right. But then if you see that the world has been all exercising, there are two things that we have noticed. Sudden death has increased. In Malaysia, sudden death is just piling up. All right, top sportsman that collapse, recreational badminton player that collapse, 16-year-old boy doing the 2.4-kilometer run as a fitness test that collapsed in a classroom after the run. People who walk the hills, come to the car, they collapse. And then the World Health Organization has also published that the worldwide NCD, the worldwide, can you see the circle on top of the bar graph? That 2008 versus 2030, the type of NCD is going to increase further. And the global mortality rate has been shown to be going up. So if the world is exercising, but why are people still dying? Why are these people still going on? When I was in Geneva having the meeting with the WHO, they have increased to reduce physical inactivities from 10% to 15% across the board. From 2015 to 2030, they've increased by 5%. All right. So if you look into this, there's a missing link here. So what we have done is that you look into the missing link. If people are exercising, there are so many fitness instructors, there are so many personal trainers, there are so many physiotherapists, so many medical doctors. What is the missing link? So we found that the missing link is the dosage. People are exercising. Yes, you see people are exercising. They're walking around the park. Could it be too much? Could it be insufficient? It's just like Professor Ashok Kumar mentioned. Do we reach the threshold to precipitate what we call the positive adaptation to positively remodel the heart? Are we doing that enough? Or are we overdoing it and causes more harm to yourself than you're not doing it? So what we want to do is that can we change the slides, please? You have to press it up very hard. Press it very hard. This one, yes. All right, okay. So if you look at that, physical inactivity is the fourth leading risk factor. Almost 500 million will die, will develop heart disease, obese, diabetes, or other NCD due to physical inactivity. Between now and 2030, that's 10 years from now. And I'm sure my country is going to suffer too, because by 2030, my country is going to be declared as an aged nation, where we have 15% of Malaysian above 60. and I'm one of them. All right. So we are all now aware that people are exercising. So it is now the role of us as an exercise scientist, rehabilitative specialists, trainers, medical fraternity. You are supposed to prescribe exercise with the right dosage to precipitate what we call the positive remodeling of the organs, or the positive adaptation that the body requires to stay healthy. My God, this okay. Now there is this word physical activity that yesterday we mentioned that exercise has been generally very misleading. Physical activity, I have found it misleading too. WHO has always mentioned to stay 150 minutes per week to stay active or any form of exercises. So when I give always a corporate talk to some corporates, they always tell me, Dr. Lee, I wash my car. I chase my children to shower. I mop the floor. I do my gardening. Those are activities. But if you look at this is the first lady doing the house chores, like what they always mention. I walk to the market. Cleaning up around the house after work prevents your body from reducing level of stress hormone. The Journal of Family Psychology. Those are stress physical activities. Then people involved in physical activities into sports. Sports is a good physical activities, but they are skills related. I can't kick a football straight. I can't play football. I can play badminton. I can play hockey. But I can't play football. So if I have neighbors around me playing football just in my village, I will never get involved in physical activity because I can't play. So let's look at something that the world can do. The world can walk. This is something that what we call non-skill related. So this is how sometimes those terminology that has been issued by world body is not well explained to the people lower down to the ground. Particularly when we are all aware that NCD hits on to the low and the middle income group. Where I assume that they are normally their education level will be also low and moderate. So this is also one of the things that we are aware of. Next, please. All right. All right. So the science behind exercise medicine, a little bit here, it's not going to be technical. Whatever food that we ingest, it comes in three forms of those macronutrients, carbohydrates, fats, and proteins. Let's not go too far. So if you look into this substrate utilization each time when we move, you will see that it's divided into 5 areas. And every time when you exercise, whether you move fast or you move slow, whether you push hard or you push slow, you have to be guided properly by your doctors. But if you look into this, between the first few seconds, we use what we call our instant energy system, which is ATP and CP. That creates the energy for you to move fast, the first few seconds. And you know what we have done with this level of energy system? With this level of energy system, we have used this very successfully with prostate cancer patients. Then we come into anaerobic glycolysis, all right? Where we break down glycogen without oxygen. That is very interesting that we found that this induces the secretion of nitrous oxide that nourishes the endothelial of our blood vessels, increases the size of the lumen and reduces tension. 70 to 80% improve fitness. Of course, we are all aware exercise medicine is not only for those people who are not well, but it's also for the general population who wants to be healthy and wants to be fit. And to achieve all those positive adaptation, you got to reach the fitness level to get them. The next one, you reach about to 60 to 70% of your maximum heart rate or your intensity. That will be the aerobically where your body breaks down glycogen. And lastly, there's the aerobic system. If you break down this energy system down, which we could call it as a cellular substrate utilization, you will find that you can treat many types of diseases. Because at each level, you will find that it produces nitrous oxide. The information, the point that Professor Hansen has mentioned in one of his paper is that when a muscle contracts, each time when we move, the muscle contracts, it becomes a secretory organ. That means they start to secrete. All right. And exercise increase the telomere length. Of course, lastly, it will change the hormonal makeup of an individual. All right. Now, these are just papers to support what has been mentioned. Exercise affect telomere length, exercise induce myokines, exercise training on the effect of nitrous oxide, and also different types of exercise to the stress system. All right. So what do we normally do when we exercise? The ladies always tells me that I don't want to be so muscular. You don't worry, you're not going to build the kind of muscles like what Professor Lim has. Show your muscles. All right. And not even men can build muscles that easy, even though you have a more advantages of the hormonal makeup compared to the female in your ratio of your testosterone. All right. So in most of the effect that in exercise medicine, we limit the type of exercise into two. One, to the musculoskeletal system. Two, into your heart and lungs. The musculoskeletal system will give you the quality of life. We have many patients that come to us and say, Lee, I need to see my daughter graduate in London. I have to travel 8 hours flying direct from KL, Kuala Lumpur to London, and I couldn't sit that long. So we give them quality of life. They want to shop 12 hours over the mall. They don't have that. And of course, in terms of a cardiorespiratory system, you don't have it, it stops, that's gone. So you gotta make sure that the heart doesn't stop pumping. So these are the two things that we focus on in exercise medicine, right? So in the protocol that we have developed that we are now operating at the exercise clinic is to perform an accurate assessment process, history taking of all those assessments accurately, that we perform this assessment exactly how medical doctors do their diagnosis. Of course, you have seen medical doctors who just put a stethoscope on your chest, pop, pop, pop. I don't know, all right? But we perform what we need to do. And then you have to prescribe a set of safe, symmetrical dose of exercise. Safe. What does the word safe means? All movements are safe, all movements are dangerous, depending on an individual. This is the first sentence that we have to induce. Number two, symmetrical. Some people have stronger left, some people have weaker right. And to make them symmetrical, we have to make sure that the dosage you use is good enough for them to build a symmetrical strength. The ratio of strength and flexibility. And then, of course, you have to instruct the exercise correctly and accurately. It is no point you tell people to walk. How do they walk? If they have flat feet, how are they going to walk? If they have high arc, how are they going to walk? If they have calcaneus spur, how are they going to walk? If they have knee pain, do you recommend where to walk? Don't just tell people walk. This is exercise medicine. It is time for us now. Now I began the fitness work back in 1984. At those days, the definition of fitness means play for fun. Later on, for more energy to play with the family. Today, we are talking about using it as a medicine. So we have come to the level that we have to be very accurate. It's no longer for fun, because there are thousands and thousands of scientific papers proven through their very, very intrinsic part of the research that have said that how exercise precipitates positive remodeling of the organ, as well as precipitate positive adaptation. So when you instruct the exercises, you have to know biomechanics. You have to understand a little bit of kinesiology. You have to understand the load. You have to understand that there are certain movements and certain architecture of the joints, in particular your shoulders, that perform most of the work when you exercise. Whether are you going to overuse it, or whether are you creating kind of abrasion on the joints, or other things that can create overuse injury over time. So the screening and assessment of the after that, you must give it to the patient. The patient must understand what are their conditions about. Do they have any bursitis? Do they have any chondromalacia? Do they have any kind of a hip pain, joint pain? So what we do is that upon doing the assessment, we will generate a report to them, a report that will also auto-generate the prescription of exercises. This software is called Dr. Fit. I built this software back in 1987 when I was in the United States. No, I like this. Can I use this? No. Because I don't like to hold something at all. Just. Sorry. Sure, this is good. So this Dr. Fit was built in 1987 when I was working for Joe Weider. All right, for the older generation here, you know who Joe Weider is. For the younger generation, you may not heard of him. All right, so when I was there, I saw a couple of types of reports, and I came back here, we developed this, and I call it Dr. Fit since then. It has been upgraded to many versions. It is in 3 versions now. It's in Mandarin, it's in Malay, my national language, and it is in English. Thank you. So 3. And this is how we want our client to know and to understand everything that is interpreted on a report. Then they know their conditions. So when we give them the report, they will probably start to exercise. I think my colleague, Aiman, where are you, Aiman? All right, he was presenting it. Unfortunately, he doesn't have enough time. So now, most of you, when you get to the gym, your instructor will tell you, you take 5 kilograms. You will obediently take 5 kilograms and do what he instructs. But the question never arises that you ask him, why 5 kilograms? If you ask him, he'll look at you and say, I think you can do 5 kilograms. And that's not science. If that's not science, that's not medicine. So we have to be very precise. Why 5 kilograms? So for example, here, how are we going to do this? Now, this is a very interesting kind of a system that I develop it during those days when I was doing my master's back in the university. And this is called the Day-2 system. It is actually used to measure the grip strength. We were doing a research on how hand grip and heart health many years ago, back in 1998. And only recently we have break this into a few pieces, and we are able to measure 5 muscles differently. So we take this, for example, we want to see someone, let's say, for example, someone who wants to lose body fat. Now, I'm not going to use the word body weight because we all understand what body weight means. Body weight could be the content of your whole body. All right, we talk about body fat. So let's say this person sitting on this bench here wants to reduce his body fat, and we do not know how many kilograms that he should do so that he can achieve the correct numbers and precipitate the good value of the adaptation. So we sit him there and we ask him to kick as hard as possible onto this, a maximum voluntary contraction. When he kicks this, it would distort a transducer where he kicks. This distortion will then be amplified, and it will show out in the interface of the computer 300 newtons. Upon kicking, we know that isometrically, this patient, his leg, his quadriceps, maximally in an isometric contraction can produce 300 newtons. Approximately, it will be 30 kilogram. What do we do then? We have this set here that if this person wants to lose body fat, we will probably ask him to do it for 15 times. 15 times or 30 times or 20 times, all right? In that sense, 30 kilogram is his maximum contraction to produce 30 kilogram. You cannot ask him to do 30 times with 30 kilogram. No way. So we will multiply 30 kilogram by 60% for those people who are inactive. 65% for those people who are moderately active, and 70% for those people who are active, or 75%. Based on that, numbers of the amount of percentage on his maximal contraction, this person will perform 50 repetitions without cheating you. We all know very well, in particular, the physiotherapist, when you do the subjective strength test, you push him harder, he will just say, let go, I can't do it anymore. But in real case, he could. Same thing when you train your athletes. You as a coach, you also would like to know whether your athletes are lying to you when you ask him to jump another 10 times or add on another 10 kilograms. So when you have this, there's no way your athlete is going to cheat you because it's proven here. So this is how we determine repetitions here. 1 to 3 repetitions, 90 to 95%. We work on neural pathway, strength, power, muscular endurance, and aerobics. So this is accurate. Onto the cardiorespiratory system, I think my colleague has completed on these slides. We also categorize them into 3 categories. And then from these 3 categories, we will subdivide them into healthy or those patients who have underlying conditions. So what are the correct exercise instruction? Number 1, we are to prevent strains. In exercise medicine, you will not have those injuries caused like in sports medicine that is being taken care by sports medicine specialists, where they will have to do a surgery on your quadriceps syndrome. You will have a broken jaw from boxing. You know, we don't have that. We are talking about strains, sprains, dislocation, chronic aches and pains, in particular, delay onset of muscle soreness. Overtraining, you tell them to come twice a week, 2 times a week, he comes every day. Or overuse injuries. This is exercise medicine that we want to prevent. I think I missed 1 slide. Oh, all right. So what we have done is that let's look at the, of course, in exercise medicine, we have gone to this. This is what we want of it. I'm not going to go through the result of this. All right, this is 1 slide that I like very much. Thank you again to Dr. Omar. There is our Director General of Health of the Ministry. And you can see our chairman sitting left. And there was me smiling, giving my speech. All right, and this was our second one. We have 2 ministers here. And this is something that I would like to also tell you all that aging has always been a category of topic in World Conference of Exercise Medicine. All right. But what I've done is that I'm going to extract this aging, and then we put it out into the International Symposium on Active Aging, which happened a couple of months ago. I think just recently only, right? So it was being initiated by our law minister at the Prime Minister's Department, Dr. Sri Azalina. She was a sports minister, and I was serving her as one of the advisors back in 2006. So we started off this, and then we are now working with the isokinetic machine, the technology of Japan. All right, and this is our signing ceremony. All right, that is our Deputy Prime Minister's at the bottom. That's my wife beside me. Can't see my daughter. All right. And then recently, the law ministers has also found that the Malaysian Prison Board, the prisoners in the jail, the high incidences of NCD, and that did not separate the wardens and the higher management of the prison board. So the Prime Minister has given the approval to set up 10 exercise clinics in the prison itself. And those who were serving long sentence will be trained, and then they will conduct exercise training for those prisoners in. And those who has been released and have graduated, they will come out and they will be placed back into the prison office to train and to teach and to instruct the prison board management and the wardens. So this is something really interesting that has been happening in exercise medicine. All right. Yeah, this is our International Active Aging Symposium. That's Dr. Lim, isn't it? There you are. All right. Dr. Dushan, you remember our first meeting? This is where we set up our first international scientific committee back in Langkawi in 2017. Dr. Omar is there. A couple of you all. All right. And this is our international scientific committee meeting. I can openly declare, not declare, tell you, inform you all that we will be having our next scientific committee meeting in February after Chinese New Year in Hong Kong. All right. And Chairman has also confirmed that the next World Conference on Exercise Medicine will be, the 7th series will be in Finland, Hannah. And we shall do, we will be doing it during winter in January, right? 2025. Okay. Okay, this is one of the interesting part. All those pictures. Yeah, the ASEAN Health Cluster. The college is also involved together with the ASEAN Health Cluster. We became one of the matrix member, and Laos is the leading country. And we had a couple of meetings during the MCO, and we are supposed to draw up the exercise protocol to combat NCD for the ASEAN countries. Oh no, there's one slide that's missing. Where's the slide of the graph? I want to show you all the heart rate return that we are using. Do you have it there, please, Chi? Now, there's a little bit things that I want to mention here before I conclude. Just give me 10 minutes before they stop me. All right, now, we are all aware that sudden death do not occur when a guy is running. Sudden death do not occur when he's chasing the shuttlecock, playing badminton. The 16-year-old boy did not die when he was running a 2.4 kilometer. He died while sitting down after the run. The Hungarian football player chased the ball, and then after chasing the ball, he was walking and he collapsed and he died. Sudden death do not die in the midst of the activity. Sudden death died after the activity. So I've spoken to many cardiologists. One of our cardiologists is Dr. Orte. He has confirmed that should there be any incidences of that, it will strike the heart, you can die during the activity. So what we have done is that if you look into the sports world, as we are all in, warming up has always been the utmost important things that we always educate our sportsmen, our neighbors, and our students. But we never tell them how to cool down properly. When they finish off their race, you ask them to limber out, put on the track pants, and they go home. But when they warm up, you tell them how many laps to run to bring their level up. So what we have done was that going through all those paper, I found a paper back in 1992. And a paper that says that the heart can stop. The heart can stop if there is a condition called hypokalemia. Hypokalemia means low in potassium. So when we are exercising, you will see that the muscle contracts, there'll be a lot of potassium being pumped out. And when you stop, because when we stop in an action during a game, we don't taper down, we stop immediately, right? So when you stop immediately, there is an activation of the vagal tone. When the vagal tone is activated, that means your blood pressure drops, everything drops. When it starts to drop, physiologically, what is going to happen is that the muscle is going to start to withdraw back all those potassium. It will go to a state where you will be hypokalemic. During this situation of hypokalemia, your heart will go through fibrillation. It will go through arrhythmia, and it can be fatal. Your heart might stop. So what we are going to do is that the paper is 1992, and of course, again, Dr. Omar's initiative, we have been approved by the ethics committee to match the secretion of potassium according to the intensity of the treadmill walk, and then how the potassium taper down according to the heart beats going down, and when can we stop. So in terms of cardiorespiratory exercises, for aerobic exercises, when you ask someone to walk on a treadmill, we will tell them warm up, cool down, and when to stop. Because if you stop abruptly, that's where the vagal tone kicks in. When it kicks in, it draws all the potassium away. So how do we tell you when to stop? We're not going to tell, we're going to ask you, are your legs okay? Are you feeling good? No. We're going to make sure that the number of heartbeats will correlate the amount of potassium in the blood that is being reabsorbed back. So this is our next research. So I'm actually very grateful that I've got friends and colleagues like Dr. Omar, Dr. Vanita, and all of you here that has made exercise medicine to every level that we are trying to achieve. Okay. Also, this is all right. This is okay. So if you look at the graph, assuming that the pre-workout exercise heart rate is 80 beats per minute, and your target heart rate is 130 beats that you are trying to achieve, your objective, you have to hit 130 beats. So we give you a 5 minutes warm up, and then after the 5 minutes warm up, you will hit the 130 beats, and you will stay at 130 beats continuously for 20 minutes. We want you to achieve the adaptation phase over 20 minutes. This calculation was done. Also, it has to fit into the industry. Because every treadmill that you can find in a gym, they have auto lock it to only 30 minutes. I used to run a gym. And the people that goes onto the treadmill, they will run and run and run for hours. And they sweat all over the treadmill. So what we do is that we limit the treadmill to be on for 30 minutes. So what we did was that everything we do, we try to industrialize it. So the moment we have achieved 20 minutes, that is when you have come to the 25th minute, we will slow down. We slow down the speed by half. And we will see what is the heart rate in the next 1 minute until the 26th minute. So in this figure here, it shows a forecast, an estimated beat of 118 beats per minute. Subtracting it from your target heart rate, it's only 12 beats, which this is the 12 beats that we are using. And this is the measurable parameter. A measurable parameter means you can tell your client that we have found that all those who are unfit when they first come to the clinic, the first minute, which is a heart rate recovery, they are always between 6, 7, 8, 6, 7, and 8. And after 3-4 times of exercises over the frequencies that they are told to do, you can see that the heart rate recovery will achieve 12 and above. All right. Then we want to see when they can stop the exercises. So what we have done is that we will use 130 minus of your pre-exercise heart rate, which gives you that you have pushed your heart 50 beats above your pre-workout exercise heart rate. All right. So we divide them by 2, which gives you 25. This 25, you add back to your pre-workout heart rate, it gives you 105. We have found that this is significant, the p-value of significance, that every 5 minutes by calculating using this formula, your heart rate will touch exactly the calculated number on the 30th minute. Now, this is what has been calculated numerically. We want to see systematically how does the potassium responding to it. So our next research is going to be quite interesting on this. All right. So basically, I call this the heart rate return. A heart rate return means how many beats your heart rate should return before you stop your activity. So based on this, on exercise medicine, we have 1, your musculoskeletal, 2, your cardiorespiratory system. All right. So that's simple, isn't it? I know this question will come. All right. Now, sometimes I answer so many times until I forget. You divide by 2 because you minus off the you reduce your entire activity by half. You see, when you're running, you can't tell yourself, I'm running at this speed. I can't run half the speed to reduce it. But on a treadmill, I can. If I'm walking at a speed of 6, when I complete, I reduce it at a speed of 3. It's not too slow, it's just half, because I subtract the elevated amount of heartbeat from your pre-workout heart rate. So I subtract it by 2. All right. Any question? It is all. That's all. That's all. Exercise medicine. Thank you very much for listening. Yes. Yes, that's a 1 RM. The machine will go at 0. Yeah, it's a 0. You just kick, that's it. Yeah. It's there. It's all there. Yeah. It was designed by my professor. Because there are instances that we use the 1 max RM like bench press to determine your bench press. We have to remember, we in exercise clinic, the patient that comes in here, most of them don't exercise. It is unfair to put them on a maximum weight on a bench press, the movements they have not done before. It's not accurate. So this would be very accurate because it's just pushing or pulling or flexing or extending, that's all. Yeah.
To get words about 1 RM,
No, we don't have to use a force brake. Now the transducer is inside the transducer, there are a lot of spring. Yes, there's a spring. When you kick, it would distort the spring. You multiply into Newton. I can't do that. Only my professor can do that. The system has been sold to the Kiev hospital for the rehabilitation. Any more questions? All right, thank you.
Yeah. Thank you, Professor Dr. Mohammad Lee, CEO, Asian College of Exercise Medicine, Malaysia. So through your presentation, you have enlightened the need and necessity of exercise medicine and sensitizing its importance for healthy world. And through your significant research as a Dr. Fit software, you are making it to the scientific world to make this exercise medicine is how important, because it is the fourth leading risk factor in inactivity of physical inactivity, and you are making all the world to become healthier through sports medicine, hopefully. Thank you, sir. Thank you for enlightening us in the field of exercise medicine.
Sir, just I request Dronacharya Sri N. Ramesh sir to come onto the stage and give away the certificate to the presenter, Dr. C.P. Lee. Yeah, please, sir. Let's all put our hands together for Dr. C.P. Lee. And I once again request all the delegates and the student delegates to kindly pay attention to the speakers and be calm while the sessions are going on, please. The chair will continue. We have the next speaker of the session, Dr. Dusan Hamar from Slovakia. And the topic on which he will be speaking is the whys and the hows of exercise for heart failure. Let's welcome Dr. Dusan.
So good day, dear chairpersons, ladies and gentlemen. You showed a lot of endurance so far. I hope there's some stamina left for the next session for remaining lectures. As it's not everyday's experience that somebody from Slovakia speaks in India, so I show you just a few slides about my country and my institution. So as you heard, I come from Slovakia, and we are a small country in Middle Europe. I mean, in terms of population, we are smaller than. In terms of population, we are smaller than. Doesn't work. Doesn't work. I don't know why. No, that's connected to. Okay. So we are smaller than Hyderabad. We are only 5.5 million people. Here you see some glimpses from my country, and this is my institution, Faculty of Physical Education and Sports at Comenius University in Bratislava, and we also have a. Let's go wrong way. Oh, yes. We also have a Center of Active Aging. That's a dedicated facility at our faculty, which is used to provide the exercise, guided exercise for the senior citizens. So that's very brief introduction of my institution. Myself, I'm a sports medicine doctor, but you know, in the past I used to spend most of the time to help the athletes, elite athletes to perform, but nowadays I'm more and more time I'm spending, you know, how to use exercise to make life of the people longer and better. So this is the topic I am about to tackle today. And I think most of you probably heard about what the heart failure means. I'm a physician, that's very well-known term. It's actually the end stage of many pathologies like ischemic heart disease, or valvular disease, hypertension, cardiomyopathies. And it's quite a frequent medical problem. Like cardiologists and general practitioners. Okay. For cardiologists and general practitioners, this is what we can call like daily bread. So they have a lot of patients with this condition.
All the participants, please be calm. Don't talk. You want to talk, you can go beside and take. Please. Thank you for cooperation.
Put it inside. So heart failure means that the heart became so weak that it's not able to pump sufficiently the blood carrying oxygen. And the main symptom of this condition is impaired tolerance to exercise and corresponding dyspnea. In extreme conditions, this impairment can be such serious that the patients have problems to breathe at rest, and they need to take a very special position in order to be able to have enough oxygen just to survive. So it's very serious, very unpleasant condition. Of course, depending on the stage, on the severity of disease, this is the worst one they can have. And as I said, the main pathogenetic factor is that the heart becomes weak, is not able to carry enough oxygen because blood is not flowing that fast as it should be. And that's the consequence is there's not enough oxygen for peripheral muscles, and there's not enough aerobic energy for exercise. The anaerobic processes have to be involved, and that causes this discomfort in terms of dyspnea. For those who are familiar with the exercise physiology, I mean, the oxygen we are using, I mean, the whole body depends on the, how much blood is, being pumped from the lungs, to the periphery, and then how much of the oxygen which this blood carries remains in the muscle. That's called like AV difference of oxygen. So it's basically like amount of the blood is a product of stroke volume and heart rate, heart frequency. So if the heart stroke volume is not high enough, then the hemodynamic becomes weak, and that's why the patient is suffering a lack of oxygen. What does it mean? What is the consequence? You heard it, what maximal oxygen uptake means. I mean, those patients have a very low maximal oxygen uptake. That, as you can see, it can be as low as 10 to 20 if you compare it to the average person, which values about 40. And early they can transport, they can use up to 90 milliliter per kilogram. So you see there's a huge difference. What does it mean? If you have a lower maximal oxygen uptake, you see that intensity of exercise, I mean, the oxygen uptake is proportional to intensity of exercise. The higher intensity of exercise, more oxygen you use in order to supply enough energy for the activity. So this is not only case for like cycle ergometer, as you see on this slide, but it's also, if you look at walking or running, I mean, the faster you walk, faster you run, more oxygen you need. When your maximal oxygen is limited, I mean, you will be limited in the velocity of running or walking. And actually for long-term exercise, we cannot use 100% of our maximal oxygen uptake. We only can do something like 50%. So if you imagine somebody who has a VO2 max only 10 milliliter per kilogram of body weight, I mean, he hardly can walk for a long time. So it's really serious impairment of tolerance to exercise. So as I said, the dyspnea is a consequence of not enough oxygen delivered to the muscles under conditions, under intensity of exercise. And Then there's a CO2 production and also lactate production. And these metabolites, they affect the receptors in arteries, in central nervous system, in lungs, and consequences that people feel discomfort. They feel they don't have enough oxygen. So it's a very unpleasant situation, as everybody knows. As long as it's at very high intensity of exercise, that's fine. But when it's very low intensity exercise, it really can affect the quality of life. So what is the main strategy in the therapy? What cardiologists use? I mean, they want to improve the heart function. And actually,
I request audience, be silence, please.
so there are drugs, especially cardiotonics, which are able to, to foster the function of the heart, and they can improve the heart function. But it's a kind of paradox that improvement of heart function, which can be measured by in terms like ejection fraction or many other parameters cardiologists use, it's not always in correlation with improvement of the tolerance to exercise. And not only that, there's experience that if somebody gets a new heart, and heart transplantation nowadays is quite a common procedure, the patients, they got a new heart. I mean, they got new pump, but it takes a time. They don't have this improved exercise tolerance, which would one expect from improved hemodynamic of the new heart, which patient receive. So, and also, as you see on this slide, there's usually not good correlation between the heart function, like in this case is ejection fraction, which shows how strong the heart works, and the maximal oxygen uptake. So there might be something different which plays a role in this impairment of exercise tolerance in the patients suffering for heart failure. And we know nowadays there are peripheral changes. I mean, changes in the peripheral vessels and in muscle cells, which are responsible at least partially for those problems the heart failure patients are suffering from, this decreased exercise tolerance. There's first of all impairment of endothelial function and cardiac output distribution. There are also changes of muscle metabolism and also the increased sensitivity of what we call ergoreceptors. So endothelial function, if body needs more blood in some parts, let's say in muscles, I mean, the appropriate arteries are, you're making wider in order to make better perfusion, to bring more blood to these tissues. And this is a normal function which is mediated by endothelial cells. But, in these patients, this function is blunted. I mean, they do not respond appropriately in opening the arteries, supplying muscles, supplying more oxygen. And that's also the factor which contributes to this discomfort, the decreased exercise tolerance. So this is the pathological process. I mean, there's a lower nitrogen oxide production and lack of relaxation of arterial smooth muscles and impairment or even missed vasodilatation and worse distribution of blood. This is the process which is a consequence of impaired endothelial function. We also have additional aggravating factors which are affecting. There's an increased adrenergic stimulation and also increased activity of this renin-angiotensin system and also thickening of basal membranes. All those factors, they are contributing to the problems to deliver the oxygen to the muscle cells where it's needed when we do exercise. And also within the muscle cells, there are changes. I mean, the activity of aerobic enzymes decreases and also mitochondrial densities, that's kind of powerhouse of the muscle, is decreased, and also the capillarization is decreased. So all those peripheral factors contribute to this impairment of exercise tolerance. Few words about the receptors. This is not very well-known phenomenon, but imagine that you do exercise, and once you stop, normally you see that ventilation goes down very fast. But imagine another situation, you blocked, for instance, one extremity that the blood cannot flow back. So it stays in those muscles. And those metabolites, they are still able, you know, to stimulate central nervous system. And you see in that case, the ventilation remains high and only later on goes down. So those are the ergoreceptors. And you see on this slide, there's a normal situation on the right slide, and you see in heart rate patient, I mean, this stimulation of ergoreceptors is like maybe 2 or 3 times higher than in the normal patients. So this also contributes to discomfort, you know, when the heart failure patient is exercising. And also, all these peripheral changes we call like peripheral myopathy. And this is one of the reasons why not only hemodynamic is important, but also, I mean, the changes in periphery are very important pathogenetic factor, which causes the problems in the patients suffering for heart failure. And in fact, there's a kind of vicious circle, because patient has a lower exercise tolerance, he tends to move, exercise less. I mean, it's deteriorating this even low fitness, and this is kind of vicious circle which has to be broken somehow, because otherwise the situation gets worse and worse. So what are the options? We have some medicaments we can use to improve this situation. And then we have exercise. I will not spend much time about medicaments, as I see that most of you are not like physicians. So there are some drugs we can use to affect this condition, like ACA inhibitors or even beta blockers. You see after treatment, you see there's after stimulation with acetylcholine, there's a slightly better response of perfusion to periphery. As you see, it's to some extent dose dependent, but it's not, I would say, major improvement. Also, beta blockers can be used to ameliorate the situation to some extent, but as I mentioned, exercise is probably the most important tool we can use to affect these peripheral changes in heart failure patients.
Audience, please concentrate to presentation.
So there are numerous studies showing that the programs from 9 to 13 weeks, consisting either from aerobic exercise or even resistance exercise, can really improve this situation quite substantially. And you see on this slide the before and after the intervention, the response is much more pronounced. This endothelial function, the perfusion, is improved by almost 200%, much more than after pharmacological treatment. And this is the fact. I mean,
Please don't talk during session. You want to talk, you can talk outside. Please cooperate this matter. Thank you.
This mechanism is contributing to improvement of the situation of the patients. The improvement of VO2 max can reach quite substantial values. We had today the presentation of Dr. Hujbala that he has similar experience with his patients, which are also candidates, or some of them might be already in the stage of heart failure. So there's improvement. you can achieve with appropriate training, like aerobic training, and also the improvement of muscle strength can reach up to 40% in some cases. Usually they start from very low, so they can improve at any stage. And also, you know, the effect of training is that in patients is decreased the resting level of catecholamines, which is stimulating hormones, and also we can see the improved heart rate variability, which is, as cardiologists know, kind of a good indicator of cardiac age, or, you know, the cardiac situation. And actually the heart rate variability, when it's losing, when the heart starts to beat like metronome, it's very bad sign, and usually it's very like very likely patient will die within few days, I would say. So, and also the exercise can decrease the ventilatory drive. So it's because of, as I showed, the sensitivity of our ergoreceptors is decreased, and also the aerobic enzyme are activated, and also the threshold for stimulation of fast twitch fibers, which produce lactate, and lactate is a factor which causes discomfort in terms of dyspnea. So these are also factors which are contributing to improvement of the exercise tolerance in heart failure patients. And also the improvement of structure and function of muscle tissues, and this decrease of adrenergic stimulation can contribute to improvement of the state of the patient. So here you see the change after intervention. This sensitivity of ergoreceptors. On the left side you see before, and the right side is after intervention. And you see that even after this occlusion, partial occlusion of exercising muscles, I mean, the drive to stimulate these receptors is much lower, and the patient doesn't feel that much discomfort in terms of dyspnea. A cardiologist know, I mean, today there was a mentioning of the various like metabolites the heart rate produces. One of those cardiologists use to assess the strain on the heart is so-called the B peptide of N-terminal fragment. And it's been shown that after exercise intervention in the heart failure patient, this indicator gets much lower value, which shows less stress on the heart in a long-term life. So very briefly, aerobic exercise, I think you are familiar with all these. I mean, just, you know, any aerobic exercise will do. Duration, frequency is common. And intensity, it should be somewhere between threshold, aerobic and anaerobic threshold. That's what works for these patients. Of course, one have to keep in mind that in absolute values, this exercise intensity may be very low, because I mean, their fitness is very low, but it's still effective. It can be like slow walking, or you know, very low intensity of cycle ergometer, but it's still, you know, effective. So you can also use the heart rate, but you know, maximal heart rate is you probably know, if you take this general formula, it can be very imprecise. So it's better, you know, take the resting heart rate and to let the patient exercise with the heart rate, which is, you know, about this resting level by 20 to 40 beats per minute. If you use the Borg scale, should be somewhere between 12 and 15. I don't have a time to go into details. I think all the people involved in exercise physiology know what I'm talking about. Resistance exercise, again, today already mentioned, it should be the weight one is able to do like 10 to 15 times. That's not too much. it's still enough, to create some positive changes. And one have to do like 1, 2, 3 reps, per major group. And it should be done 2 times a week. I mean, resistance exercise, we do not recommend to do often than 2 times because, especially the patients, they need more time to recover. So 2 times a week should be okay. So that's also a slide showing the survival. Probably the studies of Stephen Blair showing that VO2 max is the best indicator for how long we are going to live. So it's also even more pronounced if you take the patients. I mean, if you take VO2 max of the patient, heart patients, it tells you quite precisely, how long the patient is going to live. The higher VO2 max, better life expectancy. And you see on this slide, I mean, the survival of the patients with very low VO2 max was much lower or shorter than survival of those more fit subjects. Quality of life. I mean, the psychologists, they have a lot of, tests, questionnaires assessing the quality of life. This is one study showing that patients, heart failure patients, undergoing the exercise program intervention, they have a substantially better quality of life because of better exercise tolerance. So they can cope better with daily activities and they don't feel that many restrictions. There are some risks involved, but they are not serious. I think I have to finish slowly. I think it's still worth to do exercise despite of risks of some complications. They are not that serious, and I think the benefits are clear. I mean, much more pronounced than risk involved. So, very final slide. If you take this quite widely accepted Cochrane review, which updates studies, this is the conclusion that it can be used to improve the exercise tolerance, and it doesn't increase all-cause mortality, and it's really important tools to improve the quality of life of those patients. So with that, I thank you for the patience, for the endurance, and finally the few glimpses of my city, of my country. Thank you very much.
We would like to thank Dr. Hamar. Is there any comment from the floor? From the floor, shall we ask for some comments from the floor? Okay. Thank you, Dr. Hamar. And you started with the introduction to heart failure, to the importance of exercise to reduce it. Thank you very much for a good presentation. It was a bit technical, but it was quite important. Thank you.
I request Professor Deepla sir also to come and join the felicitation to the speaker. Yeah, and also to the chairpersons. Professor Deepla will be doing the honors to the chairpersons, and Professor Virender is giving the honors to the speaker. The next speaker of the morning, Dr. Hanna Wemas from Finland. She'll be talking on the social impact of exercises and benefits to learning. And to chair the session, I invite Mr. Balaji Ashokan and Dr. B. Lakshmaya.
Balaji, please come as a chairperson. Dr. P. Lakshmaya also please come.
Now, yes. No, it's on. Yeah.
For the next slide.
Okay. All right, shall I start? Is it too loud? It's not. Okay, good. Okay, very good. Is it afternoon already? I suppose it's morning in Finland, where I come from. So very good afternoon to all of you, and namaste for inviting me. First of all, I want to thank Professor Rajesh with his team. Good afternoon, Professor Rajesh. Hello. And of course, then the organizing committee of the World Conference on Exercise Medicine for for inviting me here, and also for having me in this network since 2018. So let's see now. No. Is it changing? No. Okay, I will do it here.
Long press.
Long press.
Yeah, this.
No. Okay. Okay, so most of you, well, some of you already know me, and I know many of you. It's really my pleasure to be part of this group. But since not everyone knows me, so I just briefly want to introduce myself, not talking too much about myself. I have 15 slides, by the way, so it should not take more than half an hour. So I try to stick to the schedule. But my own background really is in social sciences of sport, actually in general sociology. To get started, I gained my master's degree in general sociology, and then my PhD on sports sociology. At that time, focusing on sport-related tourism in particular. And for over 20 years, 24 years, I think, to be precise, I have been working at the University of Jyväskylä. Sometimes people ask me, so how do you pronounce this very, very strange word, Jyväskylä? And you are a physiologist, most of you. So if you think about the word cardiovascular, there you have the Jyväskylä. So maybe if you all try to say now, cardiovascular, let's say Jyväskylä. Great, sounded very good. So now you have time to rehearse this until January 25, so 1.5 years more or less. But even if you can't pronounce it, you are of course most welcome to my hometown and to my working town, which is located in Northern Europe. You see, okay, I don't see the map here, but you see the yellow, no, not yellow, but the green a little country there. So that's my home country. Finland has a population about 5.5 million. So it's a little teeny tiny corner of one of your major cities. So you can imagine it's much less people there. And yeah, For most of my career, I have worked as a senior lecturer teaching students in sport management, in social sciences of sport, and particularly international students. So you are my target group also in that sense. It's really a great pleasure to work with international students, to work with global environment. I feel that I have learned so much of different cultures and countries and physical cultures, sporting cultures. But of course, I'm also hoping that my students have learned a lot about our activities, but in Finland, but also elsewhere. In addition to my teaching obligations and teaching work, I also do research. Particularly my special research areas are sport participation globally. Why do we do certain sports in different parts of the world? Finnish people, they like walking, they like jogging, running, cross-country skiing, of course, winter sports in general, because we are in the Nordic hemisphere. But I'm also awfully curious about, let's say, I mean, we have the historical explanations, for example, cricket, field hockey being the most popular sports here in India or elsewhere. So how sport participation in general is reflecting the culture. That is my main interest area. So the societal, what is the significance, the societal significance of sport in different parts of the world? In addition to that, I've been involved with a number of other related studies, but let's not get into those now. So in addition to my teaching, my research, the third main area that I devote my working time is to be internationally active in different organizations. WCEM is one of those. I am also currently the president of the European Association of Sports Sociology, which is a very, very nice platform for sports sociologists to gather once a year and to collaborate in different types of projects. So we run an annual conference usually in the beginning of the summer, May, June. So I'm happy to also to deliver information about that to you if you are interested. So basically, this is the main background of myself. So if I move on, okay, no, this was no. Okay, oops. No, wrong way. Yep. Okay. So question. Okay. So what is I am probably the only social scientist here, right? Yeah. So what am I doing here? You may wonder. Well, first of all, I have to tell you that I'm here and I have been in this network since 2018. Because I have learned so much about physiology, exercise physiology, all of those things. I mean, all the aspects on how exercise benefits physically, different components, elements. To be honest, I did not understand too much about Professor Dushan's presentation now, to be honest. But then, for example, yesterday, a colleague and a good friend of mine, Professor Hansson, who was not able to come here this time, is doing a lot of great research on also perhaps the negative, well, maybe not the negative, but also the challenges of too much exercising. So I'm a little bit, another confession, I'm a little bit of an exercise holic. So maybe it's also something, I'm 55 years old and I spend at least 10 hours per week doing something, running, going to gym, cycling, whatever. So it goes sometimes a little crazy. I run marathons, stuff like that. So maybe for me, it's good to know to slow down sometimes. Also, I was very taken by the presentation yesterday of Professor, now the name is very, very difficult for me to pronounce, Chaudhary, who was talking about the sudden deaths of athletes and how he was telling us all to calm down sometimes. This is for me at least, but I'm sure that you also share. Sometimes you just get so carried away with nice things, even exercise, even as an amateur leisure participant, you can get carried away. But okay, that is maybe a less of a problem, because the bigger problem is how to convince people to exercise. Because so the starting point and the reason why I'm here. So I have learned a lot, but I also, the reason why I'm here, I want to give back something to this network, to this community, because I have learned so much. So I want to educate you, give you ideas that sport, exercise, physical activity, it's not just about physical elements. It's not just even how important they are. It's not just about mental things, psychological benefits. It's also about social aspects. And I'm hoping to get you interested in that field also, because I think that these three, they all go together. We talk about balance, right? And especially in where I come from, to me, you guys here in this side of the world, you are much better thinking about this balance. We Western, Nordic, Protestant people, and I'm talking about myself too, we tend to get carried away with working too much, with just, you know, achieve, which is good to a certain extent. But at the same time, we also have to keep in mind the soft things in life. Okay, so as a starting point to my presentation, still 15 slides only, maybe 13 to go, is that we all know inactivity is a global trend. We know this. We have been talking about this in this conference. We have been talking about this in previous conferences. We know it's a problem. And of course, we also know that the most evident problems are often seen in the increasing amount of physical health problems. Okay, so we talk exercise as medicine. Okay, your knee is hurting, you can't breathe well, whatever. And then you go and see the doctor, and he or she prescribes something, either like real medicine or then other things. But isn't it as important, or even more important, that we could use physical activity, exercise as medicine before the real problems occur, right? Okay, so this is what we know. Obviously, I'm not very good in technology, as you can see. Okay. Rest. Okay, so in addition to the physical benefits, physical aspects that you guys mostly are experts on, we also know that mental health problems can be associated with inactive lifestyle, or at least on the contrary, or on the other side, physical activity and exercise can enhance mental well-being. We have heard plenty of papers, presentations on this topic here. We will be hearing more, especially the friend Dr. Lim will talk about that too, and many other scholars who are specializing in sport and exercise psychology, right? We know, and we personally know, we go for a walk, we go for a run, we also feel better mentally. We know that. That is also something we already know really well. Also, moreover, another benefit in exercise is that studies, many, there are just a couple of them from Finland, but all over the world, have shown that physical activity also correlates positively with learning and academic success. So youngsters at schools who are physically active, doesn't have to be competition sports, but physically active. They walk to school, they run out in the parks freely with their friends. they usually also have a better success in, especially in mathematics, reading, writing skills, and in general, the cognitive functionality and good classroom behavior increases with exercising. Okay, so that's another good thing about it. So it's accepted. Sport can be used as medicine to prevent and to cure many illnesses, and it has many other positive effects on cognitive functionality. But then, okay, so my concern as a sports sociologist is that, yes, we know these things. I mean, there are also some disadvantages, some risks, some challenges, some dangers, but mainly it's something good if we take this exercise medicine in good doses. But the big issue is like, how can we prescribe it? And that's when the sociology or social questions come, or social concern comes into the question. So despite this knowledge that we have, people of the modern world, especially due to these lovely things that we have, we don't live in a vacuum, right? Even if I want to, all of you think about, do you want to exercise? How many of you like exercising? Hands up. Okay, and those of you who did not listen to my question, because I'm quite certain that all of us, how many of us have the possibility to exercise whenever we want? Okay, much less hands up, and still, and you are representing, we are representing a biased group, right? We are here because of this topic. But out there are plenty of people who would like to also exercise, who don't even know how to exercise, for whom the cities are too dangerous to go and exercise. The climate is either too hot or too cold, too polluted. Exercise can be very expensive. There are plenty of things, and we call them these structural things. In some societies, people work, we know examples, and Finland is one of those. People work long hours, they put in long hours, work. Japan, America, we can just think of many other countries. Here in India, maybe too. Okay. The number one reason not to participate in sport, in leisure sport in Europe, guess what it is? What's that? It's not money, it's close to that. Another one. No time, it's lack of time, and it's everywhere. So we don't have time. Why? Because we work too much, because we need to transport. We have other things. And nowadays we are hooked on these things, as good as they are in many regards. So these are structural things. Even if we have we are motivated and we like exercise, we cannot always do those things. We can not very often do those things. Culture can be something that, yeah, exercise is it's, do other things. I mean, we know that too. Sometimes, our culture is not promoting that. It's like exercise is considered sometimes like leisure. It's fun. It's too much, whatever. So our culture is maybe preventing us. Another social things, maybe you are busy, you can just think of all kinds of examples. So we know that, well, just as an example, we know, many of us know tobacco is really dangerous for you. Still people smoke. We know alcohol, or too much of alcohol, is not good for you. Still there are people.
Excuse me, madam.
Yes.
Just a briefing. Don't do briefing a short note.
I'm sorry, I didn't understand.
No.
5 minutes.
Shortly cutting, shortly.
Okay.
Yeah.
Am I talking too much? Okay. Okay. How much have I spent already? Okay, I will hurry up. Okay, so I'm obedient person. Okay, so we skip this and the okay, so what I want to emphasize just very briefly in 5 minutes, how I want to tackle this issue. There are various ways to tackle this issue, but one is, and I'm referring to my American colleagues from the University of Michigan, of this social, their measure of a definition of social impact of exercise. And this is according to the 5 following measures. We are talking about social capital, collective identities, health literacy, well-being, and human capital. And now I will go a little bit into more details. And just briefly to say why these particular measures, this is a long story, why they were chosen. But basically, these measures are chosen because they are flexible to different sports, because they can be measured at the global level, like us here. They are easily understood and kind of easily translated, and then they should efficiently address the prominent components of the construct of each variable. So we can go on. Okay, so social capital, what does it mean? It means that we have relationships and conditions, including trustworthy and diverse networks, social proactivity and participation, and community to cooperate. In other words, it means that we should, in order to enhance, in order to promote physical activity and exercise from the social aspects point of view, we should have sport clubs, voluntary sport associations, those that anyone can go based on their own willingness, their motives. It's the grassroots sports. It should not be costful. It should not be exclusive. It should be something that anyone who is interested in, let's say, cricket team, field hockey team, badminton we heard yesterday about, etc., athletics, whatever. Okay, let's go further. Collective identities are a little bit similar things, but it means that within these certain formulations of social capital, people should feel and receive the meaning of life in a way. I mean, it's not the whole meaning of life. We get meaning of life feelings from also other fields of life, but so that we get the commitment, we feel that we belong somewhere. Let's take the cricket club once again. You have like-minded people, you are appreciated there, you have fun there, you have friends there, etc., etc. So that's why, and also fitness clubs, even though they might cause some, they are like more like commercial entities, they can also serve as collective identities. You are a member of a fitness club, you know the other members, you get along, you are a part of that physical exercise family. Okay, let's move on. Health literacy is the most important thing, I think, by reading, by studying more about the benefits or the impact of sport and exercise. This is the way to educate ourselves and then to put the good word for sport and exercise. This is education is number one, definitely. If people don't know the benefits or the opportunities, how can they participate? Okay, well-being in general, it means that you have harmonious life quality, both psychologically and economically. So wherever you are, you have good living standards. And this is also our aim at so many different levels. Okay, moving on. Hurrying up a little bit. And then finally, human capital means that social impact of exercise.
Please don't talk during session. Anybody want to talk, you can go and outside and talk. Please don't talk during session.
Okay, thank you. So we need to feel good about ourselves. Human capital means that you know a skill, you want to learn a skill, knowledge, languages, the jargon as we speak, the social world. You feel that when you play cricket or when you follow cricket or whatever sport for that matter, you feel that, yes, I know this, and I want to learn more. So it's like this human capital. You feel good about yourself within this. Okay, so that's conclusions. Yeah, I went a bit faster somewhere there. Okay, but anyway, so postmodern societies where we live in, they are constructed around sedentary lifestyles in which screen time, high calorie nutrition cause illnesses and premature functional incapacities and even deaths. And in many urban, overcrowded, motorized living surroundings, natural and spontaneous physical activities are difficult to participate. So we should pay more attention in the future overall how to reach people into sport participation, because I think this is from the social point of view, from the sociological point of view, this is one of the greatest challenges. It's not that we would not like to exercise, but it's like how do we find our own forms of exercises? Okay, one more. Thank you.
Thank you, Professor Arnold, Madam, for excellent lecture on social impact and exercise and benefit of the learning. Is very informative and a motivation lecture. Social is a very important subject in the development of the physical education and the sports science and exercise of medicine. Thank you very much, Madam.
Thank you. Namaste.
Ms. Hannah, Professor Hannah, has one question.
Sir has a question.
Oh, sorry.
Yeah.
Sorry.
So as a sociologist, so the question is like the information what you provided was really nice and very impressive of the collection of the data and everything. The question is like as a athletes, as a sports person, or like those who are doing the regular people, how you are doing the differentiation from the sociologist, means like how they're behaving, the natures in the sports, how the regular people will be there. Can you please the difference in that? Because you mentioned this very clearly about that well-being and developing all those things. The differentiations, how to develop. Even nowadays also there is a good athletes, a lack of the socialism, how they're behaving outside and all. To develop that, any suggestion from your side? That's a question.
So if I understood the right, how athletes can promote, or yes.
Yeah.
Okay. Well, we know that top level Olympic sports might sometimes be far away from the health points of view, because it's another, the field is very differentiated. But of course we have also good examples that if your country, your city, your sport gets international recognition, you become a role model for youngsters. And this way, I think it's very important that we also have top level sports. It's, yeah, physically, health-wise, I'm not so sure, but socially, if a top level athlete, we have Lauri Markkanen. I don't know if you follow basketball, but he is one of the famous basketball players, and when was playing in this All-Stars team now just recently. And the interest in basketball in Finland has just like skyrocketed. And these kind of examples are really good. The top level sport and the grassroots sports, they talk to each other. Yeah.
Thank you, ma'am. Thanks a lot.
Thanks for the wonderful presentation, ma'am. I invite Dr. MBL Surya Kumari, ma'am, from G. Naranama Institute of Technology and Science for Women, to kindly felicitate the chairpersons and the speaker.
Okay. Thank you so much. Okay.
I thank the speaker and the chairpersons for this wonderful session.
Oh, one more.
So we have been hearing a lot about the sudden deaths, cardiac arrests, and the heart attacks. So we have one of our
Yeah. Okay. Thank you.
co-hosts,
Yes,
Zoll
thank you.
Technologies, who have been working on acute critical care and the rescue devices. So we have a virtual session by Dr. SM Wazin from Malaysia on the importance of AED during physical activity. He is representing the Zoll Technologies who are with us here. So I welcome Dr. Wazin. Welcome, sir. So you can kindly unmute yourself and you are visible. Thank you.
Assalamualaikum and a very good afternoon, everyone. I hope that all of you can see my presentation and hear me well. My name is
Dr.
Wazin
Wazin,
Wafa.
you are muted. I think you kindly unmute on the Zoom.
Can you hear me now? Hello, can you hear me? Assalamualaikum and good afternoon, everyone. My name is Dr. Wazin Wafa. I'm an emergency physician from Sultan Ahmad Shah Medical Center, IIUM. So for today, I'll be talking about the importance of AED in physical activity. So for those who doesn't know what AED stands for, AED is Automated External Defibrillator. About the function of the machine. But first of all, let's discuss about what is rest. So with this topic, we need to differentiate between cardiac arrest and also heart attack. So rest change.
Dr. Wazin, we have some network issue on your side. Your voice is not clear. I invite Dr. Kalimullah and Dr. Kalyan Kumar sir to kindly chair the session. Sorry for the delay. Dr. Kalimullah and Dr. Kalyan Kumar.
So the next one is the inherited channelopathies, for example, like long QT syndrome, Brugada syndrome, or catecholaminergic polymorphic VT. And the last one, you have your cardiomyopathies, which is due to the problem with the wall of the heart, such as hypertrophic cardiomyopathy, obesity, or ARVC. So this is the data that we have in Southeast Asia in one of the countries. So in 2011, it was reported about 1,300 cases of sudden cardiac arrest. So it kills more people yearly, more than cancer, stroke, and trauma. And as we can see, in the year of 2020, the rise of the cases of sudden cardiac arrest increases up to twofold to 3,432 cases. There is not much data that we have in the Asia, as most of the countries that actually look into sudden cardiac arrest in sports are mainly in Europe and the United States. So in one of the studies, it is mentioned that the incidence of sudden cardiac arrest in sports is about 1 to every 500,000 to 800,000 per year. And then in the studies as well, it is seen that is affecting more males compared to females, but this is perhaps due to the low number of women that actually participated in sports. And in the study as well, it is seen that the African American are more predisposed to sudden cardiac arrest. So as you can see in the video, this is one of the cases that happened recently in this year. So it was an American football game. So one of the players named Damar Hamlin, as you can see, was actually knocked over the chest by the opponent. So as we mentioned just now, this is one of the causes of sudden cardiac arrest that was not mentioned just now, which is traumatic chest injury. So some of the newspaper clips. So in this one, we have a student that is studying in Malaysia. So he participated in a cross country and suddenly he collapsed and died due to sudden cardiac arrest. And then in 2021, we have the famous case of Christian Eriksen, who is currently playing for Manchester United, who suffers cardiac arrest during the Euro competition. He was lucky because the condition was recognized early by the referee, and fast response by the medical team over the venue as it managed to revive him and save him from sudden cardiac arrest. And we have the latest one, the son of the famous LeBron James, who plays basketball, suffers sudden cardiac arrest during training with his team. So what happens in a cardiac arrest? Whenever that your heart fails to beat, so there will be no blood oxygen to your bodies. And as we know that our brain is very sensitive to oxygen. And whenever this thing happens, your blood will be lack of oxygen. And if you do not initiate CPR or cardiopulmonary resuscitation, after 5 minutes, there will be a permanent damage to your brain. And after 10 minutes, the chances of survival is near 0%. So in a paper of, so we don't have much data on sudden cardiac arrest in sports. However, we have more broader studies that was done in the Pan-Asian countries, which involve 7 countries. So in this study, they are looking into few things, especially they are looking into the percentage of bystander CPR and the time required by the emergency medical services to come to the cases, to attend to the cases, and then what is the outcome or the survival rate of those who suffers outside hospital cardiac arrest. So as we can see that the number of percentage of bystander CPR is very, very low. So we can see a big difference from 1.5% up till 36.7%. And if you can see the average time for the emergency medical services to response, the average is about 10 minutes, which is by the time if no CPR was done, the chances of all these patients to survive is almost 0%. And we can see that the survival rate of outside hospital cardiac arrest is very low. So the average is less than 5%, with the highest rate about 11.2%. So in a prospective studies that was done in France, they took 10 years to look into the causes of sudden cardiac arrest in sports. They can see that as you grow older, the causes are more due to the blocked vessels or ischemic heart disease. And the younger you are, the causes are more to channelopathies and also changes of the structures of your heart. Another interesting finding that from the Pero study as well, we can see that the ambulance and population ratio is very skewed in certain places. So we have certain areas in Thailand which has the ambulance to population ratio 1 to 14,000. And we have Penang, a city in Malaysia, which has the highest ambulance to population ratio. For every one ambulance, they have to cater up till 218,000 populations. So why CPR and also AED is very important? Because if you initiate the treatment early, if you recognize the condition early, you might be able to actually save the patient. Because there are three things that will determine or will increase the survival rate of someone who is having a sudden cardiac arrest. So the first one is time to CPR. Second one is high quality CPR, and the third one, time to defibrillation. So first of all, we're going to talk about the time to CPR. So as mentioned just now, without CPR, after 10 minutes, the patient have almost zero chances to survive. And you can see that if you delay chest compression for every minute, the chances to succeed will decrease from 7 to 10% every minute. So this is a timeline. So if you do not initiate any CPR within 5 minutes, the patient can have permanent brain damage. And after 10 minutes, they will probably die. So we can see between these two graphs, the difference of the probability of survival without CPR and with CPR. So if without CPR, you will reduce the chances to survive by 10% every minute. But as you can see, if you recognize early and you start your CPR early, the diminished rate is reduced by 3 to 4% every minute. So the second one, we're going to be talking about the high quality CPR. So when we talk about chest compression is not enough. For you to actually help the patient, you have to perform high quality CPR. So let's talk about what is high quality CPR. So this is based on the American Heart Association 2020 CPR and ECC guideline. So in the guideline, they mentioned that the chest compression has to be 100 to 120 beats per minute. And the depth of the compression is 5 to 6 centimeters. And you have to minimize interruption. Means that you must perform CPR at all time. And if you need to stop, it must be less than 10 seconds. And the ratio to compression to rescue breath, for every 30 compression, you have to give 2 rescue breaths. But if you are not comfortable with giving rescue breath, you can perform hands-only CPR. Means you are doing only compression without giving the rescue breath. And lastly, to allow complete recall. So let's look into it in details. So why you need to push 100 to 120 beats per minute? Because you are mimicking your heartbeat. And the chest compression 5 to 6 centimeters, because you have to ensure that you're pushing hard enough in between the spine and also the breastbone. Why you need to minimize the interruption? Because when you are doing a chest compression, you are actually building up pressures inside your heart. So the longer that you let your heart not beating or compressing your heart, you are actually reducing the pressure inside your heart. So allow complete recall. Why you need to allow the chest to recall after each compression? You are basically allowing blood to return to the heart and to allow the gas exchange to happen. So if you are doing high quality CPR, you are actually helping to deliver oxygen, blood with oxygen to the brain and to the vital organs to ensure that the patient is alive or have some chance of survival before the ambulance services arrive. And lastly, we're going to talk about time to defibrillation. So now we will be talking about the AED or automated external defibrillator. So what is AED? AED is a machine that is used to detect the electrical activity of your heart and will advise you whether the patient will need electric shock to the heart. So this machine is used in conjunction with CPR. And the two rhythm that they are detecting is ventricular fibrillation and also pulseless ventricular tachycardia. So this machine is easy to use. You don't have to be a medical professional to actually use the machine. And normally it is placed in public places so that it is accessible by anyone if they are attending anyone with a suspected cardiac arrest. So ideally, there are a lot of AED in the market, but ideally, these are the characteristics of the AED that you're looking for. First of all, AED must have a good voice prompt. Means that the instruction that is given to you is clear, simple, and easy to understand. And it has some text display so that you can see the instruction in case the environment is too noisy for you to hear. And it has lighted graphic icon so that it's easy for you to see the steps in case that you forgot your basic life support. It must be user friendly, and then it gives you every steps of the way that the things that you need to do. For example, they will advise you on how to check the response of the patient, how to open the airway, how to see if the patient has any signs of life, and of course they will be prompting you with components of high quality CPR. And a good AED also must have a real-time feedback, means that they will advise you if you are pushing too fast or pushing too slow, or if you are not pushing hard enough. Okay, in a way that it will remind you, especially if you are not used to do chest compression in your daily life. And from the studies, it has shown that AED actually helps the survival rate of sudden cardiac arrest by 2.7 times than usual. So as just now I mentioned about a study in France. So in this study as well, they actually found that more than 60% of the initial rhythm of patients who actually collapse due to sudden cardiac arrest are shockable rhythm. So which means with the AED and good high quality CPR, you can actually help to save the patient. So the AED is safe to use. So it will only detect the shockable rhythm and only give the electrical shock if they detect these two rhythms. So here are some examples of the shockable rhythm. You have your VF, which looks like irregular QRS and white QRS complex. So you have your VT or your ventricular tachycardia, which you can see more regular white QRS complex, or whether these two non-shockable rhythm, which is your normal sinus rhythm or your asystole, or normally known as flatline. So how AED actually works? So the electrical activity from the AED actually stuns the heart, which actually stops the electrical arrhythmia in your heart. So normally after it has stunned your heart with the CPR, your heart will restart again, and then it will start to beat regularly. So again, this is the chances of survival with the delay of minute to shock. Again, same with high quality CPR. If shock was not given in the first 10 minutes, the chances of survival is almost 0%. So why we need AED in sports facilities? So we can see that in Europe, soccer is or football is the commonly associated sports with sudden cardiac arrest. And then even sudden cardiac arrest is more likely to happen in an athlete rather than non-athlete. But please bear in mind that the benefit of exercise always outweigh the risk of not exercising. And I hope this will not dishearten or make you afraid to exercise. So in the video, we can see that this was during the Euro 2021 when Christian Eriksen had a cardiac arrest. We can see in the picture that CPR was initiated on the field by the paramedics, and he was actually shocked using AED. And if you can see the longer footage in YouTube, you can see that he actually alert leaving the field, which is a very good outcome neurologically and also physically. So when we talk about sudden cardiac arrest in athlete, so the risk is 2.5 times higher compared to non-athlete. And most of the athlete doesn't have any symptoms. So which makes this condition is very tricky to detect and for you to suspect. And then, as I mentioned just now, even though that trauma can cause sudden cardiac arrest, but it only contributes about 6% of the total cases. So most of the cases of sudden cardiac arrest in sports are due to medical causes. So with the usage of AED, we can see that the outcome of the patient is better. And most of the happy stories that we heard in the news is due to the high quality CPR and also defibrillation. So whenever that you have AED at your facilities, you can actually help to reduce the risk of someone dying. And then you can actually buy some time before the patient can be sent to the hospital. So you must take in mind as well, if your sports facilities are away or located quite remote, it is a very good idea for you to have an AED. So this is a video of one good outcome cases that occurs in Malaysia. Let's spend some time to watch this video.
I request the Wazin to conclude the session within 10 minutes.
Sorry, let me try to share the audio. Hold on.
So Professor Wazin, please conclude.
Okay. So why Zoll? So we have we can see that from the Zoll EED, it actually fits all the ideals EED that we mentioned just now, and then we can see that the improvement in all the machines from time to time actually helps to actually save more lives. So the take-home message is learn your CPR make sure that you know how to use AED and you have an AED at your sports facilities. And hopefully at the end, you can save more life. Okay, so another take-home message, the only wrong thing that you may do when there is a sudden cardiac arrest is not doing anything. So don't wait to be heroes, be the hero. With that, anything can happen, anyone can help, you can make the difference. Thank you very much. Any questions, you can email it to me.
Thank you, Professor Vasin. It's a wonderful presentation, and we're observing the services of Joel here. And any questions from the audience? No. Okay.
Thank you, Professor Wazin, for joining us virtually and explaining the importance of AED. I request Professor Rajesh Kumar sir to honor the chairpersons. Professor Rajesh Kumar sir will be honoring the chairpersons, Dr. Kalimula and Dr. Kalyan Kumar. Thank you, sir. And the last speaker before lunch will be Dr. V. Srikant Babu. The topic, impact of exercise type and dosage on pain and disability. The chairpersons, Dr. G. Sunita and Dr. Kumudini. I request the chairpersons and the speaker to kindly come onto the stage.
Dear participants, the lunch is in progress and the conference also in progress. Please, one batch of the delegates went for lunch. Slowly, after the session is going on, you can go for lunch and you can present here. But as per my request, Srikant is the international presenter. Please stay for some time. Then we are going to have the workshop demonstration. Then online session will be there. This is the announcement I am telling. Please sit down, madam. Don't go. Only boys went. Girls will go. Yes, madam, sit down. After some time, you can go.
A very good afternoon. This one up, is it?
For the next slide.
A very good afternoon to all the handsome guys and beautiful girls here. Am I audible? Everyone hungry? Okay, I'll make my session very short. So everyone, after the session, you can have your lunch. Okay, right. Yesterday, after the first session, when we are going back to our hotel, my colleague, Dr. Hasbullah, asked me one question. Doc, you're loyal to India or loyal to Malaysia? Okay. So I told him, I am loyal to India. I told him I am loyal to India because India is my motherland. Yes, no doubt, I'm 100% loyal to India. And I also told him I am 101% loyal to Malaysia as well, because that is my mother-in-law's land. My wife is from there. Okay, right. Every time I used to tell my colleagues, my Malaysian colleagues, that my motherland, India, is very hospitable. People here are very hospitable and disciplined. Come, let's show everyone, the whole world, that India is hospitable and disciplined. Okay, right. So today I'm going to talk about a topic which is this is not staying at all. Okay, which is very common, and most of you will be either hearing about it or going through this at your home. Is there any person here where in your house your parents or grandparents complaining about knee pain? Right? This is very, very common. You can click it. Okay, thank you. Thank you. Okay, this is very common problem faced by many people in our house, right? So today we are going to talk about this topic we call osteoarthritis, or very in a layman word, knee pain, right? So we are going to talk about the impact of exercise type and dosage. What are the types of exercises and what dosage of exercises is good for people who are having osteoarthritis, knee pain, especially if the person is obese, overweight or obese. So always obesity and knee pain or osteoarthritis, they are associated, very closely associated. So let's see. By the way, I'm a physiotherapist by profession, and I work very closely with medical professionals, medical practitioners, nurses, occupational therapists, and exercise specialists. I believe that rehabilitation is not complete if the teamwork is not there. In the team, everyone is important, right? So in a rehabilitation team, as much as the doctor is important, physiotherapists and occupational therapists and medical practitioners are also important. So briefly today, I'm going to talk about osteoarthritis. What is osteoarthritis and how a person will obtain osteoarthritis, how he will develop it, and what are the symptoms of osteoarthritis, and what are the management options available, and how exercises are going to prevent the osteoarthritis, or how it will help in managing osteoarthritis. As we all know, osteoarthritis is a degenerative disorder of the joint. Here, most of you or some of you will eat chicken, right? Right. So when you're eating the chicken, end of the bone, sometimes you see a soft layer, white colored layer, right? That is called cartilage. So we all have the cartilage as well at the end of the bone. So when we are growing, that cartilage will become thin. When the cartilage becomes thin, all the problems will start, right? So it's a degenerative disorder of the joint where the cartilage becomes thin, or sometimes it's broken, exposing the underlying bone. We call this in a scientific way called as osteoarthritis. Okay, and this osteoarthritis is now the fourth leading cause of disability. Just imagine you're actively moving around, going to shopping, playing with your colleagues, right? Spending time with your family. Let's say you develop this osteoarthritis, suddenly you started the knee pain, and you cannot, have a social life. You cannot go out. You cannot spend time with your family. Okay, you're asking your mother, "Mom, come, let's go for shopping." She want to come, but because of the knee pain, she's scared. She might be troubling you, so she will tell, "Sorry, I cannot come today." I have heard from many of my clients who are having osteoarthritis complaining their main problem is they cannot go for shopping. This is very sympathetic. Osteoarthritis also It can affect any part of the body. It can come in your neck, it can come in your hip, it can come in your knee, ankles, every part of the body. And most commonly, arthritis affects the knee joint because they are the weight-taking joints in the body. Okay, after the knee osteoarthritis, hip osteoarthritis of the hand, these are all common. Okay, any part of the body which is weight-bearing can develop osteoarthritis. And this osteoarthritis causes a lot of changes in the body, where it leads to a person to depend on something else for their mobility. Either they need help from someone, to move around. Either they need something, external gadget, like, maybe a frame or a wheelchair to move from place to place. Okay, it increases the dependency of a person. If you see the epidemiology of osteoarthritis, there are about 250 million people around the world suffering with any form of osteoarthritis, which can be prevented actually. And then if you see in India, back in 1990, 23.46 million people are suffering with osteoarthritis. In a decade period, about 10 years time, almost three times of the population, 62.35 million people are suffering with osteoarthritis. That means the osteoarthritis, the prevalence rate increased by 3-folds. And then most people with osteoarthritis are of working age. Normally, if we see knee pain, usually we think, oh, after 60 years or 70 years only we develop. No, now it has been changed. I have a client in my clinic. You believe it or not, he's only 26 years old. 26 years old, suffering with knee pain. What may be the reason? 26 years old, but he is 130 kgs. 130 kgs for his height. His height is about 5.5. So he's already into second grade of obesity. He developed knee pain. Just imagine the rest of his life he has to suffer with knee pain. His quality of life will be diminished. He cannot move out and go out and combine with his friends and spend time with his friends, right? So that is the impact of osteoarthritis on our lives. If you see the etiology of osteoarthritis, what are the causes of osteoarthritis? We can categorize osteoarthritis into two types: primary osteoarthritis and secondary osteoarthritis. Let's say a person is growing, changes happening in the body. Along with the changes, there will be changes in the cells of the cartilage, and degeneration happens. It's very natural. It is unavoidable. Everyone here have to go through this at one particular point of your life. If a person is developing osteoarthritis without any reason or because of mechanical factors, we call it as primary osteoarthritis. There is no reason, probably because of weight falling on the joints. And we have another category of people who develop osteoarthritis. This is not based on the age. This is based on some other factors. It can be because of injury. Sometimes when you're young, you might develop injuries over the knee, or your knee joint. Maybe it can be, the lower end of your thigh or the upper end of the leg. It can be a fracture of the femur or fracture of tibia or fibula or around the joints. So that time you don't have anything. Everything is clear. They will be treated, either conservatively or surgically. That time is okay. But as you keep going, maybe after 10 years or 15 years, this is the time where you start your knee pain. This is because already some mechanical changes happen in the joint and the weight bearing surfaces have been changed. I just give one simple example. For example, a person is weighing 50 kgs, standing straight. 25 kgs falls on one leg and another 25 kgs falls on the other leg, right? The same person sitting in a chair and waking up, almost double the body weight falls on the joint. If a person is climbing the stairs or running, 3 times the body weight falls on the leg. Just imagine. If the person is obese, overweight, so what happens to the knee? Definitely it's going to go through the degenerative changes, right? So any injury to the happening to the joint, it can cause osteoarthritis. Or sometimes when a child is born, the child is born with some deformities of the joint. Either it can be a knock knee or we call it as bow legs. It can be a bow leg, zenu varum, zenu valgus, a lot of congenital deformities are there. These congenital deformities also can change the direction of the weight bearing surfaces, and it leads to damage to the cartilage, either inner side or outer side early. And we have some other congenital problems, or we call it as subcutaneous issues, something like Ehlers-Danlos syndrome, and then some other factors like obesity, which also is a leading risk factor for developing osteoarthritis. I'm not going very deep into pathogenesis, but what happens in the joint? Let's say a person is about to develop osteoarthritis. What changes happens inside? To make it very simple, inside the cartilage we have collagen fibers, which are protein fibers. These collagen fibers are well organized. When a person is growing, there will be disorganization of these collagen fibers, and there will be breakdown of the collagen fibers, which further lead to breakdown of proteoglycans, and the organization of the proteoglycans will change, leading to weakness in the cartilage and later leading to cracks in the cartilage. This will initiate the process of degeneration. If you see the features of osteoarthritis, if you ask your grandma, you're having knee pain, what other problems you're having? They'll be telling, oh, I'm having knee pain. I cannot stand longer time, or I cannot cook longer time. I cannot bend my knee completely. If I am bending, there are sounds coming, click, click sounds. So they'll have knee pain, they'll have stiffness in the joints, they'll have cracking sounds coming from the joint. Sometimes knee will be locked. They'll be walking, suddenly lock. They cannot make it straight, they have to force it. This is because of locking of the cartilage. And then also it leads to functional disabilities. They cannot move from place to place. It limits their social engagements. So osteoarthritis is a main problem which causes physical barrier, and it leads to disconnect. They will disconnect them from the society. If you see obesity, always obesity and osteoarthritis are interrelated. A person having osteoarthritis, they cannot walk around, they cannot move around, so they put on weight. They cannot do exercise, right? A person who is having obesity, a lot of loads fall on the joint, they develop osteoarthritis. So always both are interdependent. As I told, the weight loading on the joint will increase as the body weight increases, loads falling on the joint also increases. So people who are obese, they develop osteoarthritis very easily. If you see the management of osteoarthritis, there are many management approaches. We cannot actually segregate them. There are many management approaches which helps people to overcome their knee pain. Okay, if you see, most important thing is lifestyle changes, lifestyle modification. A person who is sedentary, staying at the house, watching TV, like to eat their favorite food, okay, which is more in carbs. This one lead to, obesity, later leading to osteoarthritis, right? So changes in their lifestyle can have an impact on the osteoarthritis and the obesity as well. And physical exercises. Physical exercises helps to reduce the impact on the joints, okay, helps to reduce obesity, helps to reduce knee pain. And along with physical exercises, if a person is having osteoarthritis, usually first thing they do, they will try everything at home. Okay, they will try to put some balm, amrutanjan or something, right? They try to put some hot pack, won't work out. Then they go to medical store, they will try to get some medicine taken. Sometimes it works, sometimes it won't work. Then they go to see a doctor. Doctor will advise them to go and take an X-ray, and probably based upon the category of osteoarthritis, they may prescribe some pain medication, right? Or sometimes they may ask to undergo intra-articular injection, either a corticosteroid or now recently like PRP injections, which are a bit effective. Then if nothing works out and the severity of osteoarthritis is high, they may ask you to go for knee replacement surgery, right? So all these are options which the person can choose based upon their problem. When we see all these things, what important thing coming out is prevention is better than cure, right? So let's see. If you see the exercises, see a person who is having osteoarthritis, someone who is obese, you cannot directly prescribe them exercise. It can harm them, right? So always, it's a holistic approach where you will present them with a diet recommendation along with something which reduces their pain, either pain medication or, I'm a physiotherapist. So when I talk in physiotherapy aspect, we go with pain, reducing modalities. We reduce the pain, then we prescribe exercise. Then the patient, can take it. When a person is having knee pain, you ask him to go and do exercise. Do you think he goes? Definitely he won't go. He will say, okay, doctor, then go home, take rest, right? So it's always advisable to work on their pain. Then we recommend exercise, okay? And prescribing exercise to a person who is having knee osteoarthritis and who is non-obese is easy than to prescribe an exercise to a person who is having osteoarthritis and obese, right? So always there is no gold standard of, exercise prescription to a person who is obese and having osteoarthritis. It's always personally, tailored exercise is always better for the person. It always, depends upon the severity of osteoarthritis, at what grade the person is having osteoarthritis, and what are the symptoms at that time they are executing. If you see exercise recommendations, in general, if we talk about osteoarthritis, we can recommend exercise in two ways. One is non-weight bearing exercises. The other approach is weight bearing exercise. Okay, non-weight bearing exercise is exercise where the person will be doing the exercise with the other end of the leg free in the air. That means, for example, you do a knee curl, okay, putting some weight on the ankle. This is non-weight bearing exercise. If you ask the person to squat, this is weight bearing exercise. Okay, if you see the knee, one end of the knee is always, attached to the body. You cannot take it out. But the other end, either, you can attach to something else or you can make it free. When it is moving freely, we call it as open kinetic exercise, or also we call it as non-weight bearing exercise. And If the other end is, attached with something like cycling, right? Or walking on a treadmill, okay, it is close kinematic exercise, or we call it as, okay, weight bearing exercise. There are many forms of exercise which we can choose, we can handpick to prescribe to our clients. If you see non-weight bearing exercise, for example, okay, non-weight bearing exercise, few to name: static quadriceps exercise, where we ask the person to just lie down and press the knee down. Press the knee down and hold for 10 count and release. This is, nothing weight is falling on the knee, but we can see some isometric contractions of the muscles around the knee. This will create intra-articular tension, intramuscular tension, which helps to improve or maintain the muscle properties. Okay. Then we have something called straight leg raises. Person will be either in lying down or sitting. Then we ask the person to lift up the leg. For effectiveness, we can put some weight on the ankle. This is another form of non-weight bearing exercise. And we have in standing, we can ask them to hold something, put some weight, and either we can, ask them to bend or, go side, go in front. All these exercises are non-weight bearing exercises, which helps to improve the strength of the muscles around your knee joint. Okay. And now, this is more in recommendation, pool exercises. Doing exercise in a pool is very effective for obese people, because when you're standing in water and doing some exercise, like moving your leg or, whatever exercise you're doing inside the pool, weight won't fall on the knees. So this is very effective. That's why a lot of, commercial treadmill trainers and, commercial treadmill manufacturers, and then cycling, they are coming up with something called hydropool, hydropool cycles, hydropool treadmills, these kind of things, which are very effective in improving the muscle strength without, taking more weight on the joints, right? And if you see the other side of the exercise, which are weight bearing exercises, where we do either, cycling. I don't say cycling, as a weight bearing. It is a form of non-weight bearing also, because you'll be sitting and then, when you cycle, weight won't fall on the knees. Okay, other forms like, standing heel raises this way, or squatting, and then running, single leg standing, all these exercises are weight bearing exercises. So we can prescribe a person with osteoarthritis either non-weight bearing exercise or weight bearing exercise. It also, let's say, like non-weight bearing is safe for everyone. Whether the person is obese or not, non-weight bearing exercise are good. If a person is obese, then we have to see.
Can you please conclude?
Sure. Then we have to check which type of exercise you have to pick up and prescribe to the people who are obese. There's a study done. There's a study done on people. Here the author gave. They formed two groups, and they prescribe exercises to one group. They prescribe weight bearing exercise, and another group they prescribe non-weight bearing exercises. And they did the study for 12 weeks. The results of the study says that non-weight bearing exercises, people with obesity, and the BMI more than 30, when they are given exercises, especially non-weight bearing exercises, they feel more, pain less. They pay less. The pain is less. And on a scale of 10 centimeters VAS score, the reading is low. So non-weight bearing, they tell that non-weight bearing exercises are very advisable for people who are obese. At the same time, weight bearing exercises are also equally effective, especially when coming to improving the strength of the knees and also to improve the proprioception of the knees. So non-weight bearing exercise and weight bearing exercise both are effective and safe to give to people who are having osteoarthritis and obesity. But when we are giving weight bearing exercise, you have to see at what category of osteoarthritis they belong. There is another study, which is 8-week study done on people with osteoarthritis and who are obese. They gave 3 forms of exercise: low impact aerobic exercises, weight bearing exercises, and functional exercises. And the results of the study shows all the 3 forms of exercise are good for people who are having osteoarthritis and obesity. But if you are giving single exercise at a time is more effective than combining everything and giving, right? And they also says that the weight bearing exercises will help to improve the joint position sense and also helps to improve their walking pattern. And we have another study which is done to know the type and dosage of exercises for people who are having osteoarthritis. The results of the study shows that 12 weeks of supervised exercise are effective in improving the knee pain and knee function in people who are having osteoarthritis. And there is another study which shows the relation between obesity and the relationship between obesity and the physical function. The results of the study shows that obesity measured by BMI leads to reduced physical function, physical activity over a period of 6 years. And from all these studies, we can say that people with knee osteoarthritis, actually, if you see people with knee osteoarthritis, they cannot do 150 minutes, what the requirements of physical activity, 150 minutes of moderate exercise or 75 minutes of intense exercise. But with the help of some external gadgets, like for example, cardiac walkers or wearing a knee brace, they can complete the task, and it helps them to overcome their disability or disorder. So the take-home message from my presentation is osteoarthritis is something unavoidable, but we can delay the development of osteoarthritis. Let's say a person is already having osteoarthritis. It is always advisable to start the exercise early, to give at least 12 sessions of supervised exercise, and we can either give non-weight bearing exercise or weight bearing exercises to them in a safe way, right? Thank you very much. This is
Thank you, Shrikant sir. The session was very nice. You have very well elaborated and explained about in detail about osteoarthritis. You have even very well explained what exactly are the lacunas and what exactly the problems which have been faced. You have even explained about the exercises which is going to be very helpful for the people. And at the outset, your session was a very good session, sir. Thank you so much.
Thank you.
Thank you, Dr. Srikanth. So I request Dr. Lim Boon Hui. Dr. Lim, sir, I request you to kindly come onto the stage and give you the certificates to the presenter and the chairpersons. Dr. Lim Boon Hui. Yeah, yes, sir. So the delegates can break for lunch, and those who have finished the lunch, kindly come and sit back. So we have 2 virtual sessions now. So the delegates can move for lunch, and the people who have completed lunch, kindly I request you to sit back. We have 2 international speakers, one from Italy and one from Pakistan, who will be joining us virtually. I request the delegates who have finished their lunch and the students of GCPE, those who have finished the lunch, please come and occupy your seats. Thank you. So we have two speakers online to join us, and thank you, Dr. Lim. I invite Dr. Jairam and Dr. Vishnuvardhan from the Central University of Tamil Nadu to join us on stage to chair the virtual sessions. Others can break for lunch, and those who have finished the lunch kindly come back. Dr. Domenico, welcome to this World Conference on Exercise Medicine.
Hello, good morning. Thank
The
you for
session
having
is
me.
on, and I just request you to hold on for a minute as we set up the chairpersons and the technical thing. Dalit, voice. Yeah, Domenico, can you just go ahead?
Okay, thank you very much. I hope you can hear me. Is that all right? Do I receive confirmation you can hear and see?
Sir, just a minute, sir. I'm sorry for disturbing you. We have some small technical issue. Just hold on for 2 minutes. Yeah. Only these two are left over. Okay. And the workshop. Yeah. Are we going to a workshop? Yeah. First, these two will be virtual. By the time you want to finish your lunch and come back, then we will have the workshop. So these two first, after that will be workshop. Sir, can you talk once?
Hello, here I am. Okay, I'm talking. Can you hear me now?
Sir, did you unmute yourself? Yeah.
No. No.
Yeah,
Can
kindly
you hear
speak.
me now? Hello?
Yeah, a little bit louder.
Okay. Can you hear me now if I speak this way?
Yeah, yes, sir. Yes, sir. Be a little louder and you are visible.
Okay, I'll try again. Can you hear me now? This is the maximum. Can you hear me now?
Yeah, you are audible.
Okay, I ran a test as well. So can we proceed or do we have the workshop first?
So your voice is low. Audio input is a little bit low there.
This is at maximum from my side. Connection is very good. It's 55 mega two-way.
Hello.
Hello.
Sir, can you speak louder?
I'm speaking very loud. They're hearing me up to the 3rd floor now. I'm trying to put a little mic if it helps. Okay, you hear me now?
Yeah. Now it's fine, sir. Please go ahead.
Okay. Okay, now it's better. Let's go ahead. Okay, thank you very much. Sorry for technical delay. And I wish to thank all the organizers, all the friends I meet in Malaysia and around the world several times, and the new Indian friends. So this is a pleasure. And I really, as I wrote on the common chat, I miss you all. Okay, now I share my screen so we can go through this short discussion. I don't see it. Okay, let me try. Okay, let me try to share the screen once again. Okay, is this it?
Yes, please proceed.
Okay, very well. So thank you very much. As you know, I'm talking from Italy. I'll make my long story short. Most of you know me, and I have several commitments that are not listed being part of this wonderful team. The presentation goes as also in a way that is a reference tool for everyone and mostly the students. And there are several papers that constitute the bigger part of what we need to know and rehearse and repeat and reminders. And there are some papers, mostly from the Americans, but also, and that will be the most important, from our European friends. So they're related to the amount of exercise, to the adaptation, and to see what happens in the heart. This is a very simple chart highlighting and trying to put a pointer from here. Okay, I think where you increase the static component with the different exercises, the dynamic component. So we don't go from something actually simple in terms of energy expenditure, cricket and golf, don't hate me, please, to something more heavy, demanding, like decathlon and rowing. These activities do act as changes on the heart, increasing the level of hypertrophy, which could be concentric, so increasing the thickness, or eccentric, increasing the dilatation of both. So the different kind of exercise will have a direct effect on the heart and will be beneficial or not according to the level of exercise. And the exercise can be used for primary prevention before anything happens and secondary prevention after an event. And today we concentrate on the primary prevention. You very well know that the consequences of physical activity include physical inactivity, include low cardiorespiratory fitness, obesity, dyslipidemia, hypertension, insulin resistance that will lead to obesity, dyslipidemia, hypertension per se, and hyperglycemia. And chronic physical activity is associated with increase of diabetes, coronary heart disease, heart failure, stroke, cardiovascular event, and mortality. It is a disaster. It is such a disaster that physical activity is responsible for approximately 10% of all global deaths worldwide. That's what we're here to promote, to have people walking and doing. The gold standard for assessment of cardiorespiratory fitness is VO2 max. We heard this earlier before by Dr. Hansen. And VO2 max is measured the highest VO2 during an exercise test. It is a very practical way of measuring how people behave during exercise. In at-risk populations, such as overweight, obese, or older adults, aerobic exercise training typically increases cardiorespiratory fitness in excess of 1 MET. Each 1 MET improvement is associated with an important 13 to 15% reduction of all-cause mortality and cardiovascular events. So we all know very well, but this is a thing that we can try to explain to our patients. Do that, and the probability of death is greatly, of having a stroke or something else, is greatly reduced. And the action on the organs, and don't think the organs are only liver, heart, or muscles, but all the vessels are an organ. And there are several actions that can happen throughout the different type of exercise, like the capillary density, the energy expenditure, the body weight, all the metabolic activities, I'm cutting it short, a reduction in blood pressure, and increased function of the heart by means of stroke volume, the amount of blood which is pumped every second. You already know that we can titrate exercise according to moderate and high intensity, short interval, long interval, full recovery, and moderate intensity continuously. So the different combination could be useful in different settings. This is the reference papers I was mentioning shortly ago. It's done by the expert group from the European Society of Cardiology, European Association of Preventive Cardiology, and they do provide a lot of interesting recipes. Let's go by definition and by parts. First part, hypertension. Everybody knows that the blood pressure 160 is high, but these are the latest definition, the latest guidelines that came up in June 2023. And we wish to focus in primary prevention to these two levels, 140 to 160, 130 to 140, which have been defined high normal. In these people, at least 75 in the high normal and 50% of the people in grade 1 hypertension can revert to normal or optimal blood pressure by only means of exercising. And this is very important. What can we prescribe? Aerobic exercise training supplemented with some level of dynamic resistance training of moderate intensity, 40–50% of the heart rate reserve for at least 30 minutes per day, continuously or intermittently in bouts of at least 10 minutes, at least 5 days per week. This is the first recipe. In patients with low cardiovascular risk, because so they're only hypertensive and nothing else, we can add vigorous exercise training at 60–80% of the heart rate reserve. A single exercise may cause an acute reduction in blood pressure that lasts for several hours. So daily aerobic exercise training should be emphasized in the hypertensive patient greater so than the typical guideline suggested 5 days per week. We can add some certain level of dynamic resistance at moderate intensity in several repetitions at 5 exercises at twice a week if the persons there are capable and active to do that. Safety precautions. Inform patients if they have prodromal symptoms, take care, do an evaluation how I can do it. No heavy lifting. Some of them are trying to do more in order to achieve more. Since a strong heavy lifting, you all know better than me, have a strong isometric component, the alpha-adrenergic stimulation increases blood pressure. So it's not what we want. And if the resting systolic blood pressure is greater than 160, do not prescribe high intensity training or maximal exercise training. In this kind of person, maybe you can consider having them medically supervised with an exercise test before the planning. So think of that. The rule of the thumb is it's only hypertensive, you can go ahead. It has several other risk factors. One initial exercise testing or possibly cardiopulmonary exercise could be useful. What does exercise achieve? Aerobic and resistance exercise training reduce systolic and diastolic blood pressure 2 to 5 in normotensive and 5 to 7 in hypertensive. This seems little, but it is the action that is similar to medications. And in a large study going across more than 300,000 patients, an average reduction of blood pressure of 5 millimeters reduced by 10% cardiovascular events. So it's very important. Think not at the individual, think of at the group level, at the patient you are assessing, or if you're in health authority at the population level. This is great. And there are some patients that have resistant hypertension, meaning the blood pressure is very high and stays high despite all medications. In these people, a combined lifestyle intervention, obviously structured aerobic exercise training, behavioral weight management, and dietary counseling reduces blood pressure very, very well. 12 versus 7. And the 12 you've seen is very important, because if 5 creates an effect, is very useful. Let's change topic. Obesity. This is the dissemination of obesity in 1990, and this is 2019. We don't have the latest 2023 figures yet, but it's increasing worldwide. You know very well, with the change of unfortunate change in eating habits. In Italy, with a group of other professors, we managed to create a document to strengthen the fact that obesity is not only a risk factor, is a disease among cardiologists, because obesity is not the shift from the fridge to the belly of food, but as several mechanical and biochemical inflammatory actions, which are very dangerous. If we think of obesity management, okay, we have to achieve with weight loss, but we have to maintain it throughout time. And this is where exercise comes into action, because weight loss will improve all other risk factors: blood pressure, triglyceride, cholesterol, as we know, but in a very significant way over time. Sorry, here we are. What is the target? The target is to lower adipose tissue and to reduce BMI, but the simpler thing is to measure waist circumference, less than 94 for males and 80 for females. Unfortunately, these data are not still not yet related to individual average size of individuals in the countries. So probably the thresholds are lower. It is well known since several years, on a 40 years long study, that reducing the waist circumference within normal limits reduces the incidence of stroke at 10 years by 40%. So scare your people. Tell your patient, you want to avoid stroke and end up on a wheelchair, reduce your weight. What can be done? A lot of things. Weekly aerobic exercise at 250 minutes per week, not the 150 for hypertension, or at least 1,500 kilocalories, and a permanently lifelong increased physical activity. Program duration should be at least 6 months to see the effects. It's not shorter than that. And try to keep people exercising lifetime to minimize body weight regain. Maximize total caloric expenditure, adding moderate intensity exercise involving large muscle groups. Cycling should be only used as a warming up for a limited duration, because the energy expenditure is not that much as a global exercise plan. And training frequency should start at 3 and build up to 5 days per week. And low intensity aerobic exercise is not suggested because it has no effect on the long term. The addition of resistant exercise is warranted to increase resting caloric expenditure with all the biological effects that we've seen. So the typical suggestion is 12 to 15 repetitions of 3 series targeting large muscle groups. You might wonder why I did that picture of a very lean lady, and it was recently from this journal in April. So this is something, and the leverage you have to do, and you're doing, is with the public communication. With hearing that obesity goes with osteoarthritis. So patients are aware that they can limit their activity. So tailor up on what we're hearing just before this morning, before me. The action of obesity, and these are papers that I suggest for everybody to read, are beyond the loss of the weight reduction, but the effect on long term are very important. So to reduce visceral fat, because visceral fat, once again, is not an accumulation, but is an active organ producing sort of hormones, adipokines, that are deleterious to the whole body and the circulatory systems. Dyslipidemia. Dyslipidemia is currently defined as LDL levels, the bad cholesterol, greater than 100 for low risk, high risk patients, and greater than 70 for very risk patients. So we have a very strong target that is usually tackled with medication, but exercise is most often implemented to improve blood lipids. Usually maybe preferred moderate intensity exercise in prolonged exercise sessions, at least 40-minute session in a long term, 40 weeks and possibly a year. And as obesity, select exercise modes with the greatest caloric expenditure. Resistance training might increase slightly also the good cholesterol, which has protective effect, and prescribe lean tissue mass increasing resistance exercise training at from 8 to 10 repetition of each series at 70–85% for 3 series of exercise. So it's quite an effort. So it will be the leverage that you have with your patients that we have obtaining that, because the effect of this of exercise on dyslipidemia are beyond the attenuation of risk factor per se, because for instance increases the endothelial function, increases the release of NO, and as I mentioned before, the vasculature is an organ. Increasing that flow is very important because it reduces arterial stiffness also in hypertension. So the global effect is not only on the heart, it's on all the circulation. So exercising for dyslipidemia, apart from reducing bad cholesterol levels, is very helpful for all the cardiovascular system. Also in components that emerged as crucial, like chronic inflammation of the vascular system and increasing the level of production of endothelial progenitor cells that do protect the vessel from the atherosclerotic damage. And this is very clear. A meta-analysis showed that if we compare aerobic exercise, diet, or both on lipid control, well, the winner is a combination. So have your patient dieting and do exercise, which is much better. Last but not least, diabetes. This is very tough, but I have a few examples in a few visual slides that we can go through as to stay in time. We have to reduce the average glucose level as measured by HbA1c, less than 7% of 52 millimoles. And the standard and base activity is walking, at least daily, at least 30 minutes for the typical 150 moderate intensity or 90 minutes per week of vigorous intensity, ideally 3–4 hours per week. So you have to balance according to the type of patients you have. That's the minimum. You can keep going. And the energy expenditure should be put up between 1,000 and 2,000 kilocalories per week. It will require at least 2 weeks to start seeing a reduction of HbA1c. But you have to promote exercise in a program of lasting at least 6 months and then increase the level of activity. Resistance training can be added because it improves insulin sensitivity and glycemic control in all major muscle groups. An example is to set per muscle group, 8 to 12 repetition at 70, 80%, or 25 to 30 repetition at 40 to 55%. You know these measurements better than me because I'm a cardiologist and not an exercise trainer, as many of you are. The next two slides are 2 quick examples of a Canadian organization that fights diabetes, and have a very nice example of documentation to give to the patient. So I encourage all groups to start doing something like this, to hand out as a handout to your patient, and you check what can be done for them or what is advisable for them to do. There are some safety, last 2 slides, precautions that we have to do with diabetic patients. It is useful to measure glucose before, during, at the end. If the patient has a risk of hyperglycemia and the optimal glucose level, the range is very good. So do not exercise someone that has a glucose level before the exercise greater than 300. Or if he had an hypoglycemic episodes in the latest 24 hours. When there is hyperglycemia, there is a production of ketones that are byproduct of the metabolism that are found in the urines. Individuals can check the presence of ketones, which are very dangerous to the muscle, to the liver, to the heart, to the brain, with a simple stick in their urine. So advise this kind of patient to check them regularly. If the patient has polyuria, dehydration, drinking during exercise could be useful. If you have in the medical history have signs of kidney failure, avoid exercise if blood pressure is greater than 200 and avoid Valsalva maneuver. If there is retinopathy, reduce the exercise intensity of 75% of the VO2 max. Avoid activities high impact like jumps and the Valsalva maneuver because a direct acute retinal damage can occur. And you know that long-term chronic diabetes patients with or without neuropathy or peripheral artery disease could have some lesions. So check them before exercise intervention and yearly. If there are foot lesions, there are no weight-bearing exercises to be done, and advise to have proper footwear. If the patient has diabetic autonomic neuropathy, check on anomalies on cardiovascular function by the presence of resting tachycardia or orthostatic hypotension or inappropriate heart rate changes before and after exercise. They are at increased risk of coronary and artery disease and cardiovascular disease in general. So a cardiovascular examination ahead of exercise plan is strongly advised. Last slide, another comment that happens usually. Most of the patients are taking lipid-lowering drugs like statins. And many of these patients, in excess of the actual myocardial damage, are reporting muscle pain. Prolonged moderate intensity exercise does not increase muscle injury, both in asymptomatic or asymptomatic statin user. That means that if the patient is statin, can keep going. So with this, I wish to thank you all for the time you gave to me, and I really hope to be with you all next time. Thanks a lot.
Thank you. Domenico sir, we are missing you.
Yep. Okay, thank you very much. This was quite interesting communication I wish to give. I advise the technical team that the PDF for the slides is available for sharing if anybody wishes, because the reference is very useful also mainly for students. Thank you very much.
So thank you very much for wonderful presentation, sir. It is from Italy. One question they want to ask, sir. Your question I will.
Yes, please. Yes, please.
Professor C.P. Lee is going to ask you a question.
Okay.
Hello, Italy. How are you?
Hello, Dr. Lee. Nice talking to you.
Yes. All right. Your last slide, you have mentioned that you can, those who are on statin, they can continue to work out.
Yeah.
All right. What's your advice for those who are on statin? But most of the time, the statin will cause muscular ache.
This is the point. Okay, the title, I put that to promote discussion, both in symptomatic and asymptomatic patients. Not strenuous exercise can be pursued. Also, the statin pain and the statin muscle damage are slightly different. I always wish to report, it is old, 2 years old, a very nice study, 3 arms, in which one set of patients, 1,500 patients were taking statins, 105 patients are taking placebo, and 1,500 were taking none. So they were not scared of having statin-related muscular disease. And the net result was that the number of reported muscular pain and discomfort was equal between statin and placebo, but 0 in the person that were not even taking placebo. So the worldwide scare of statin is greater than the bad effect of those.
Madam, please come. Sit down here.
Okay, okay. All right. Thanks. Because this is one of the complaints that mostly patients will always say that,
Absolutely.
The pain is killing me. All right. Thanks.
You're welcome.
Thank you very much, sir, for a wonderful talk. So certificate we will send you by mail.
Thank you very much. It is a pleasure and an honor.
Then we are having another session, exercise dosage in pediatric disability, but a speaker is not seen online. Sir, Dr. Sipili, sir, a speaker from Pakistan not seen. I can call the Zol people for the demonstration. Speaker is online? Not online, I think so. Okay, chairpersons, please take care of the Zol project. After that, you please take care of this also. Zol, their practical demonstration they are doing.
Hello, hello. Good afternoon, everyone. Hi, I hope those that have come back from lunch, you are ready for some exercise. And those that have not gone to lunch, I hope you will do some exercise before you go for lunch, although it's a bit late for lunch now. Well, very good afternoon to everyone. My name is Shani, and this is my colleague, Vijay. We're from Zoe Medical, the company that sells and manufacture and sells the AED, as you can see behind. So this is the second part of the presentation that we have today. Earlier, you've heard the speaker from Zoe, which is Dr. Wazian, online, because he was supposed to make it today. He was supposed to be here, but he couldn't come because he didn't get his visa approved, unfortunately, right? So it was very sad. So this is the second part of our presentation today, where we're going to do a demo. So obviously, I'm not here to prescribe any medication. Okay, I'm really not that level. Okay, so what we're doing today is We're actually demoing a skill, right? A life-saving skill. Okay, so can I have a show of hands? Okay, who knows what is CPR? Cardiopulmonary resuscitation. CPR. Who knows what's CPR? Okay, that's good. Okay, another question. You should know, right? Because Dr. Wazian actually presented it a while ago. Okay, so next question. So who knows what is high quality CPR? Oops. Oops. I only see my colleague at the back there, way back there, like, oh, I know. Okay, good. So there is a very big difference between CPR and high quality CPR, right? Because CPR does not help you save a life. But high quality CPR is the essence, is the important key to help a sudden cardiac arrest victim survive the incident, right? So we talk a lot about AED. In fact, we're a company that sells AED. But today, I'm here to talk about high quality CPR, right? Because by having the AED alone doesn't save the life. You need to have two things. You need to be able to perform high quality CPR with your two hands, okay? And you need to have an AED, right? The failure, I mean, we understand sometimes you don't have an AED nearby. It may take a while before the emergency services comes, right? So the survival of the victim actually depends on how well of a CPR, a high quality CPR you can perform. Why? Okay. Now, as you can see from the earlier presentation, when a person goes into a sudden cardiac arrest, and I must emphasize this, right? Sudden cardiac arrest happens to anyone, right? Regardless, it can happen to anyone. So unlike heart attack, whereby it happens to people with underlying, heart problems, or you have the, hypertension or whatever, heart problems or other issues, right? Health issues that may lead to heart attack, right? But sudden cardiac arrest can happen to very, very healthy people, right? So you can see if you are into sports news and all those, right? Very, very healthy sports people out there, right? People who do sports like as a career, right? They suffer sudden cardiac arrest. And that is why we have a tagline to say that anything can happen, but anyone can help. The good part about this is anyone can help, because you don't have to be a doctor, you don't have to be a medical personnel, you don't have to be a paramedic. Any lay responder, any student out there, right, who knows about high quality CPR and know how to just press the button, one button on the AED to turn it on and one to shock, you're able to save a person's life. Okay. Now, when I talk about high quality CPR, why is it high quality CPR versus CPR, right? So when a person goes into sudden cardiac arrest, the heart stops, right? The heart stops, meaning what does the heart actually do? What's the function of the heart? Pumps the blood, right? So it pumps the blood, not only the blood, because the blood brings oxygen to all parts of the body and especially the brain. Now, when the heart stops, right, no oxygen is being flown to the brain. And if you don't do a high quality CPR to help the victim, right, in the progress while waiting for the AED to come or waiting for ambulance to come to resuscitate the heart, right? If there's no oxygen being flown to the brain for more than 10 minutes, right, the brain is dead, totally irreversible, right? So our objective here today of trying to get people to learn high quality CPR, the skill of high quality CPR, is our objective is we want people to recover from sudden cardiac arrest neurologically intact, right? We don't want people to survive a cardiac arrest, but you become vegetative, means you're in a coma for the rest of your life in the hospital. That doesn't help, right? So the brain has about 10 minutes of golden time, right? So the longer it is without oxygen, more damage will happen to it. So if you have known friends or you've read stories about people having cardiac arrest and they actually are lucky enough to survive from it, but they may lose some memories like, oh, I forgot what happened today, or I forgot what happened in the past 1 week, because there's certain damage to the brain because there was no oxygen to the brain for maybe 3 minutes, 5 minutes, that kind of thing. Right. So I'm going to do a very quick demo. I'm not going to go into very clinical details about it because, Dr. Wazian has gone through it earlier. So we're going to do a very quick demo. And after this demo here, we have stations being set there for hands-on. You can move there, go there and try and, compress and try to do CPR, right? Now, so what's the ZOL AED? So I talked about high quality CPR, right? Now, imagine this. If I ask you to drive on a road, all of you can drive, right? I assume. Okay. If I ask you to drive on a road, a mountainy road at night, totally dark, no lights. Okay. Do you think you can drive safely? Do you think you'll be able to drive? Right. The answer is no. So now I'm telling you that high quality CPR has a few criteria, right? Number one, the depth must be between 5 to 6 centimeters, right? The rate between 100 to 120 compressions per minute, right? Full recoil, you must make sure you full recoil, and then you must have minimal stoppage time of the CPR in between, right? So these are the criteria of high quality CPR. But if I give you a mannequin today now and you compress, how do you know it's between 5 to 6 centimeters? There is no ruler there to show you that this is 5 or 6 centimeters. It may be 3, it may be 8 centimeters, right? So this is the example that I'm giving earlier where I'm asking you to drive at night without giving you the lights. Right now, the ZOL AED, yes, every AED in the market is the same, whereby it gives the current to defibrillate the heart. But the additional technology that we have is that it provides you, the driver, okay, which is the rescuer in this case, the light to see when you're driving at night. Meaning now you don't know what is 5 to 6 centimeters. You don't know what is 100 to 120 compressions per minute. There's no measurement for you, right? So the measurement is within the AED itself, meaning besides providing the defibrillation to the heart, it also guides the responder, okay, to perform high quality CPR. And that is why, okay, the ZOL AED is FDA approved, okay, to say that our technology of rail CPR feedback technology is able to increase the chances of survival, okay, for our victim by more than 2.7 times versus any other AEDs out there. Okay, so I'm going to go on with the thing. Okay, the first, at the onset of an emergency, the first thing that you have to do, okay, who can give me an answer? You get a gift from our booth later. Yeah, actually, there's a gift. We have lots of gifts there. Okay, see, my colleague is there waiting to give out the gifts. At the onset of any emergency, what's the first step? Not yet. We haven't come to that yet. You are right. Hey, she gets a gift. Right. Danger. D. Very good. Okay. Danger. Why? Correct. Ensure that everywhere the scene of your life saving is safe for you to perform any rescue. Right? Imagine you're at a roadside or somewhere that is maybe not safe. Imagine if it's happening at a nearby, maybe a fire or something. I mean, cardiac arrest can happen anywhere, right? So the important thing is it's not only safe for the victim because he's practically the heart stopped anyway, right? But it has to be safe for yourself, because if something happens to you, who's going to save him and who's going to save you, right? So number one, check your surrounding. Okay. Number two,
call for the CPR ambulance.
what is it?
Call for the CPR ambulance.
Okay, call for
Activate
help.
the emergency.
Call for help. So the answer is call for help. Okay. Sudeep, he gets another gift.
Dr. Dakne is correct.
Yeah. Right. Right. Second step, call for help. Right. Okay. So if you're not the only person at the scene, say you have somebody with you, right? The right thing to do is give instruction to the other people. You call for help. You go get the AED, right? So instruct somebody while you can attend to the victim, okay, to start CPR. So before the AED comes, it's only human, right? It's only you and the victim. But it's not lost because the most powerful tool is actually your hands, right? And in your hands is with you. So it's only you and the victim. Please start CPR immediately, right? And that I can assure you will help you save the victim. Right. So as I go along, you want to start doing?
I can.
Okay. So VJ, my colleague here, will show you how he, do the rescue, check for the surrounding, bring the AED, and then, check. Right. So somebody was saying check breathing. It's not wrong too, right? So the next step is to check breathing. After you have instructed people to call for help, go and get the AEDs and all those, the next one, before you start to do anything, you're right, check breathing. Right? After you check the breathing, why do we have to check breathing?
Okay, one of the vital sign to check whether chest is expanding or not,
Yeah.
breathing is there or not. Look, listen, feel. You have to do within 10 seconds. Suppose you are not a clinically trained person, but at least check for the response first. Hello, mister, madam, hello. No response. No response means it might be a cardiac arrest. If response is there, or like some neurological problem like Mirgika attack, we say, na, the movement will be there, right? So that is not a cardiac arrest. If because of the low BP fall down, or hypoglycemia, like low sugar, he fall down, he may respond you. When you are tapping on his shoulder, he may respond you. So that is not a cardiac arrest. When the no response, no communication from the victim, then definitely it is a cardiac arrest. Then as sir told, call for a cardiac ambulance. When you call 108, put your phone on a speaker phone, okay? Tell them that one person is there. I suspect it is a cardiac arrest. Please send cardiac ambulance. There are two kind of ambulances in India. One is patient transport ambulance and one is ALS or a cardiac ambulance. So please specify, I need a cardiac ambulance. You tell the space where it is, wherever the victim place, you define that. You tell them categorically bring cardiac ambulance. Okay. So first thing you have done, check the response. Chest is look, listen, feel, you have done. Okay. You now sure that it is a cardiac arrest. You start the CPR. Now I will tell you where is the CPR point. All rib cage joint point. This is called as xiphoid bone. Okay. You check everybody. Do you have that or not? A small soft joint, right? After that, 2 inches above it and the breast line. This hard surface area is your CPR point. Okay. Breast line, imaginary breast line, you can see, right? And my zippy bone, above that zippy bone, 2 inches. This is my CPR point. See, when the victim is collapsed, like we are normal, 100% circulation going on, but victim is collapsed. When you give external CPR, only 30 to 40% of circulation is happening. If you don't do correctly, high quality CPR, if you don't give, then that 30 to 40% will not be happening, right? So very important to give at correct position and high quality CPR as mentioned in the guidelines, right? Yes, go ahead.
Okay. So after doing all the check, okay, assume the AED has arrived, right? So you can go on. Okay, so the first thing, obviously, turn on the AED and then place the pads.
Unit okay.
Okay, so
Automatic defibrillator. Adult pads. Don't touch patient. Analyzing. Don't touch patient. Analyzing.
okay, so if you heard what the AED is saying, right? It says no, it's don't touch patient, it's analyzing, right? So the important thing that we want to say is that the AED is really created or catered for non-medical responders like us, right? So you don't have to worry
Check pass.
whether the patient is having a cardiac arrest or not. Sometimes lay responders like me, okay, we may not know if the person
Check
is
pass.
really in cardiac arrest or not, right? So the important
Don't
thing
touch
is
patient.
place the pads. As soon as
Analyzing.
if the person is still unconscious, just face the pads, because the AED is
Don't
smart
touch patient.
enough to
Analyzing.
analyze the heart rhythm and tell you whether is there a shock needed or not, right?
Don't touch
The AED
patient.
is smart enough
Shock
that
will be
if
delivered
there
in
is
3,
the person is not in
2,
cardiac arrest,
1.
there is no shock needed,
Shock
okay,
delivered.
it will not say
Start
shock needed.
CPR.
It will not even charge
Push
up.
to match
So
the
you
tone.
cannot, kill a patient more than what is already being done, right? Now, so this is a CPR. Later, you can go to the booth and look at the feedback, right? So as he's compressing, right, you will see a bar that's coming down
Give
here,
2 breaths.
right?
If you are having ambu bag with you,
Continue
pocket mask,
CPR.
give 2 breath. Otherwise, just
Continue CPR.
Post-COVID guidelines said you can do hands only CPR, like 100 to 120 compressions
Continue
per minute. You
CPR.
can do hands only, no need to give breath. Suppose, but in home, suppose my daughter, my son collapses or my mother collapses, I have to give. I know
Continue
the known
CPR.
person, you can give mouth breath. Otherwise, just hands only CPR, continue CPR, right?
So one of the criteria of high quality CPR is minimize interruptions. So what he has done just now, he has not minimized his interruptions. He stopped and talked a lot, right? So the device has actually said many times to remind you continue CPR, right? So it actually detects real time what you're doing, right? To tell you that you have to continue CPR, right? If you stop. Do stop. If he's not deep enough,
Push harder.
did you hear that?
Push harder.
So it says push harder because it is detected that he did not achieve between 5 to 6 centimeters.
Push harder. Stop CPR.
Every 2 minutes, it will say stop CPR to analyze if there's a shockable rhythm.
Shock will be delivered in 3, 2, 1. Shock delivered. Start CPR.
And then you continue CPR.
the top.
Okay, so a lot of people ask, should you continue CPR until when, right? Number one, either he wakes up and say, hey, it's very painful, can you please stop CPR, right? Or there's actually movements, meaning he's awake, right? Or number two, professional help comes, which is the ambulance comes and take over the scene.
Continue CPR.
All right, right. So
Continue CPR. Unit
okay.
powering off.
Okay, so that's what our demo is today. Any questions from the audience? We would like to take questions if there's any regarding cardiac arrest, regarding the AEDs. Yeah. Okay.
Sir, if your machine is not there, then how to count the numbers?
What was the question?
Suppose AED is not there, tick tick sound is not there, metronome is there, not there. How to count the numbers?
Okay, so very good question, right? So your question is regarding the example that I gave earlier where you're driving without light, right? So if you're forced to drive, if it's an emergency, you have no choice but to continue to drive. Let's say there's a tiger chasing you behind. You have to continue driving because whether you drive or you just stay there, you're going to die anyway, right? Okay, you still have to continue driving. So at that point, what you need to do is you will have to just use your best instincts, right, to go on, right? So that's why two things is important here. Number one, to have the guide from the device is important. Failing which, training is actually very important. So if we are able, right, so in your school, in your education, or in your office, or wherever in your organization, right? If you're able to run certain form of trainings for your people, at least they get a feel of what it feels like, the speed of doing 100 to 120 compressions per minute, at least they've been through it, right? So the answer to you is, if there is no guide to it, unfortunately, it's through your best instincts. Right. That's why I mentioned earlier why the Zoll AD with this real CPR help guide is able to increase survival, because you don't have to do the guessing work. It gives you the measurement. Yes, next question. Did I answer the question?
Shani,
Thank you.
Shani, just to answer the sir. So you can do one thing also, like you can just, when you're counting, you can just count like that 1 and 2 and 3. So there is a gap, or you can count like 1001, 1002, 1003. So that you can just count it, but it is all your own mind how you count, and you have to maintain that speed. The speed has to be 100 to 120 per minute.
Yes. Okay, yes.
I have a question to a question. This is suppose if there is a pregnant female, how do we go about it? Do they get a cardiac arrest? And if they are pregnant, what should we do?
Okay, so for anybody, whether it's a woman, it's a man, pregnant woman or not, right? You continue to do CPR regardless, right? If it's a cardiac arrest, right, you still continue to do CPR. You continue to put on the AED pads, right? And you continue to defibrillate the patient regardless of whether it is pregnant or not. And to answer this, we actually have a case where we managed, our AED was used to defibrillate a pregnant woman, right? And she survived. Okay, yes.
Yeah, to answer your question, when a cardiac arrest happens in a pregnant woman, what you do is the posture you take is slightly different. You turn the patient from the right to the left. It's called left uterine displacement, and then start the CPR. It's like that. Otherwise, everything is same. The rate, the compression, the depth of compression, everything is the same, except that you turn the patient from the right to the left. It's called LUD, lateral uterine displacement. That's all. That's the only difference. Yes, and that too, this has to be taken place, CPR has to be given only in the 3rd trimester, not in the first 2 trimesters, when the uterus size grows. That's when you give CPR. And at the same time, when you give CPR in the 3rd trimester, suppose the patient revives, immediately shift her to the recovery position, what you call it, and immediately take her to the hospital for an emergency cesarean section. Otherwise, the patient will not survive, or the baby will also die. Right?
Okay.
Does it answer your question? Thank you.
Thank you, doctor. We will take one last question from the lady. Yeah, because time is short, but please proceed to the station later and we will answer more questions. Yes. Pardon? Oh, okay, good question. Right, so her question, let me repeat it. Her question is there any age limit for the device, right? So very, very good question. The AEDs, right, it's actually manufactured for both pediatric and adults, right, child and adults. So as you can see here, another unique function of our pads is that it is a uni-pads, right, universally used pads for both pediatric and adults. The only difference is for adults, you stick the pads anterior, means both front, right? For pediatric, because their body is smaller, right? So you can't stick both pads on the front of the body. So one side of the pads goes behind. So it's front and back positioning of the pads, right? And on the device here, because kids and adults, the algorithm of the heart is different, right? If the device detects, don't
Automatic defibrillator. Stay calm. Check responsiveness. Call for help. Open airway.
okay, so there's actually okay, there's actually a button down here, if you can see, that you can change the mode of the defibrillator from an adult to a child, right? So that the device will know that it's a child, and when it analyzes the child, when it analyzes the patient, right, it will use the pediatric algorithm to analyze the child, because if you know, a child's heart rate is always faster than an adult, right? So when a child, the algorithm is different from an adult, so it has to be analyzed differently to be able to detect that the child is in cardiac arrest or not. Yeah. Okay, so that will be the last question for today. Thank you very much. Do go to our stations. We will take further questions at the station.
I think we need to have a 10 numbers each batches. Hi, everyone. We will have 4 counters there. So we will need 10 each counter. So you can split accordingly. So once every 15 minutes, we will change the batches. Okay, so there will be 4 batches. One batches consist of 10 people. So can you please coordinate yourself and arrange, come across to all the 4 counters?
Thank you so much, the entire team of Zoll team, for a wonderful presentation on high quality CPR. Thank you so much.
I request Professor Rathod sir, please come. 2 minutes, function will be over. Please cooperate. I request Professor Rathod sir, Vice Chancellor of Parliament University, to honor certificates to chairpersons. Certificate. अरे सर्टिफिकेट ऑनर सर्टिफिकेट दे रहे भाई, ये स्पीकर का भी दे रहा, मेरे सर्टिफिकेट है ऑनर। हाँ, 2 सर्टिफिकेट दे। All of you, please sit down here. We are going to have national anthem, please. All of you come here, boys. Please come here. We are going to have a national anthem, please. Afterwards, you want to do, you do. Afterwards, you can do practice. Vishnu, Rasko repair. All of you sit down within 2 minutes, so function is over. Jaram sir. Please cooperate. Momentous. Very well done demonstration by Zoll people. We are honoring with memento. Thank you very much to all. I'm extremely sorry that foreign delegates are not get the proper lunch, but evening we are having a dinner also, big dinner. Please excuse us for that, madam. Vanita madam, please excuse us. We have celebrated your birthday also. Yeah, on that day also, because this lunch was not hosted by us. The school is hosted. They have counted wrong. Delegates. They counted 200, but the people eaten food is 300. Huh? Okay, please excuse us. Tara Singh, where are the host people? Okay. I request Tara Singh to propose the vote of thanks.
So we have come to the end of day 2 successfully. And day 3 will be at Vidya Jyoti Institute of Technology, Aziz Nagar, which is a sister concern institution of Anurag University. And the organizers there will be waiting to welcome you all tomorrow. And on behalf of the IFP, FSSA and the organizing committee, I thank each and every delegate who have come so long out of the city to enjoy this lush green campus of the Gaudium School. And I'm thankful to the organizers, the co-hosts, the Gaudium School, the management and the faculty of the Gaudium School, and all the students who have come from GCP and all the other delegates. So once again, I'm thankful to all of you. And before we actually wind up, let's have the national anthem.
Okay, all of you please come, get up. Madam, please stop. National anthem going to happen. Anita, please join for national anthem. Army man, Ajay. कर्णमना दीनायक जय है भारत वागे विधाता पंजाब सिंध गुजरात मराठा विला उच्चल वंगा हिमाचल यमुना गंगा
उज्जल जन सिद्धरंगा तव शुभ नाम जागे तव शुभ आशीष मांगे गाये तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you very much. Jai Hind. Thank you very much.
This one.